you doing? I'm gonna go ahead and try to pin you here. Let me see.
I'm good. How are you doing?
I'm good, thank you.
Oh, it looks like we have a sub interpreter from Rise. It says a Rise interpreter.
Okay.
Oh, Hannah, never mind. Hopefully it's the same interpreter from last week.
Okay. Let's see if I can pin. So I'll pin yours and then I'll pin the other interpreter. Okay, I guess we'll go ahead and get started. How's everybody doing? Good. So today we're gonna work on hardware a little more, and we're gonna focus a little bit more on desktop. We had previously discussed that we are using. Last week we talked about laptop repair. This week we're gonna touch a little bit on desktop components and repair. So if you can access Canvas and download the notes and the assignments in the lab for today. Okay. Before we start, do you have any questions for me? I know I needed to add some link for you regarding PC parts and some information about data recovery. I'll add that to the course today. Okay. All right, so I'm going to go into screen share. If you have any questions, please either unmute and ask, or if you want, you can type it in chat. But I will occasionally check chat throughout, not immediately, because sometime in screen share, I'm not able to see chat. So this week we are going to look at desktop hardware. And where we left off last week was cabling and different types of cable. So I want to follow up with that because some of you might consider pursuing certification CompTIA A+, which consists of a lot of questions related to hardware and some software components. So let me open up my notes. To start in our notes, we are going to go over some cables. So if you follow along in the notes, and then occasionally we will answer the questions in our assignments. Let me open that up. Sorry. So as you go through and troubleshoot your system, sometimes you don't see video signal on your monitor or on your screen. So we have to look at the type of video cables that we are working with. So in the notes to start, it begins with talking about different video cables. And different type of cables have different type of signal. Currently, we're using HDMI, which gives you digital and analog, meaning that you can use that single cable to give you sound and video. Where in VGA, it only gives you the video, and then you have to connect the sound via speaker. Or if you are looking at DisplayPort, which is still very common, DisplayPort is digital and analog. So we're going to go through all different types of cable, and we're going to talk about the use and how to troubleshoot video. So to start, last off, we left off with VGA, which is the cable that uses VGA has the blue end and it has 2 screws on the side. And VGA, it was for a long time the analog display standard. You still see some VGA today in TV, monitor, and different types of screen. So it has been around since the 90s. And what you also have is the advanced version of it, which is the SVGA. And with the SVGA, you have the higher resolution, 800 by 600. So now when you're looking at the connector, anytime that you see the pins, they're often referred to as male connector. And the DB stands, this is the standard type of connector, which is DB. The reason why they name it DB is because the shape of it looks like the D, and then the pin number is 15. So when you're looking at the cable, if you see the 15 pins, usually that will be included in the connector number. M stands for the male. Now, if you're looking at the cable and it has holes to receive the pin, that will be a female, which is indicated as F. Okay? So that will be DB15F. And it all depends, but most of the time we would see that the VGA would be the male cable. So here on the second page, it shows you what the male would look like and what the female would look like. So if you have this is the adapter, which is the female end, and then this is the cable, which is the male end. And as you can see, it's shaped like a D, okay? And then it has 15 pins. So on the cable, that will be DB15M, and then on the adapter, that will be DB15F. Okay. Now you want to secure it using the screw on both sides, so make sure we insert the pin correctly. We want to check for bent pin too. So in the case where you plug it in and it's not showing video signal when you turn on the computer, you first need to check the connection, right, and the power. So we need to check to make sure that the screen power button is pressed on. Also, the computer needs to be on, or the system needs to be on. Sometimes the user would make that mistake. Also, to check and make sure that the cable connection is secure, meaning that is it loose? If it's loose, you want to make sure that you connect it correctly. So with the HDMI, we should also check the cable, but we don't run into issues with the bent pin because the pin is housed inside the metal connector. So there's no more issue with bent pin. So in the past, this is what we use, and this is called VGA. Now, after that, what they did was they implemented another type of connection, which is DVI. And port just referred to the physical connection or a logical connection. Okay. So now, in some cases, you might have the adapter that would go from VGA and convert it to DVI. And the benefit of using DVI is that it is faster. It is a later technology. DVI stands for Digital Visual Interface Port. And there are different types of DVI. As you can see, there's a DVI-I, and then there's a DVI-D. Okay, so the DVI-D, usually what you see supporting LCD display, and sometimes you still see DVI being sold on video card or on monitor and screens. So this is what it would look like for the DVI. And it supports both digital and analog. And again, we would have the 2 screws on both ends, very similar to the VGA. Pin sizes are different. Okay, so here is the female on the left and the male on the right. Okay, so again, if we don't see video signal, we check for power, we check for cable connection, and then we can start moving the troubleshooting approach to the other area, right? Is it using a video card? Is that video card securely installed? Okay. So we can check. So I normally test cable with a good known cable. So in the field, when you do this in technical world, you would be equipped with an additional cable so that way you can check. So at home, if you're using DVI or VGA and you're not seeing signal, a quick way you can test if it's a bad cable, sometimes that could be the case, especially with USB, then you would use a known good cable, right, to plug it in and test. So this is a DVI. Any question with VGA and DVI? So I want to go over, yes, question?
Oh, no, sorry, no.
No problem.
Thank you.
So I want to go over a few more things before we start labeling our video card ports. So the one that we commonly use today is the HDMI. And HDMI stands for High Definition Multimedia Interface. As the user demands more high definition output, the industry produced technology that would give you clearer picture, crisper sound. So HDMI supports both digital and analog. Now that allows you to have connection to your home theater system equipment, along with if you use HDMI cable to connect your computer to your monitor. So HDMI is often used for interfacing video. So when we say interfacing, mean we're connecting, right? We're connecting to that system. Now that gives us higher definition. So this is what you see with the 4K and the 8K and the 5K in the market, is because of the capability of the interface that have changed over the years. In the past, we weren't able to utilize higher definition using VGA or DVI. Remember that SVGA was only 800 by 600. So, you know, the picture was not as clear on our monitor or our screen. But with HDMI, what you see is, yes, you can go lower, but it will be 1080. So most of the time you would see that's the standard now, which is approximately 1K, and then we can go up to higher. Also, we produce software and technology like game, right, for the higher definition like 4K. So in your HDMI connection, you have type A. Okay. So when you're looking at a cable, let me see if I have one here.
I have a question.
Sure.
Is it really an advantage to get the gold-plated HDMI?
It's just gold plated give you better, longer lasting because it doesn't oxidize compared to other form of metal.
Oh, okay.
Yeah. So, and sometimes you buy higher quality HDMI, those, and because how it's insulated, meaning that in the cable, if you're looking at a lot of these cable, right? A lot of the times, even though it's wrapped on the outside, sometimes it's not wrapped on the inside. So as you use it, sometimes you would bend it a certain way, and over time, that can break the internal copper wire because all of these are copper. So what happened is a lot of the companies, they spend a little bit more in cost producing the cable in such that it will be better insulated and better wrapped, along with using a better connector. So with these, because sometimes we would touch it with our hands, or it could get weathered down, there's environment with moisture, so sometimes that can cause it to oxidize or rust. So what will happen is if you spend a little bit more money with the gold plated, all that means is that the connector is going to last a little longer. But then if they built the cable to be not as good, then it's no good to have a good connector anyways. Some of it is really, to the brand. I know that like, Monster and some of the other brand of cable, they only produce gold plated cable. I did buy some gold plate back then, but because now I think that cable price had dropped tremendously for all different types, right? Because there's a huge demand for it and people mass produce it. So, and they have to be competitive, supply and demand. So you see that it's often that people would just buy a cheaper cable because you can quickly replace that with another good cable for a few dollars versus $50. So when you're looking at the cable, whether it's HDMI or USB, the large end of the cable is always going to be type A. Okay. So in the HDMI cable, that the connection that you plug into the back of your TV or your monitor, that's the type A. Okay. Now HDMI, most common HDMI has 19 pins. And we're not talking about the mini and micro yet here, right? And the standard definition for that is 1920 by 1080. So this is why you often see now that a lot of the display, the minimum that you're gonna see, right, for pixel is 1080 pixel. Okay, so that's like at least 1K. So it's pretty, it's pretty high definition compared to what we had before, right? And then we can always increase it to 4K and 5K. Okay. Okay. Any questions regarding HDMI? All right. So with the mini HDMI, that actually came shortly after the regular HDMI, which is smaller. Okay. And the connector, they call this the type C. And then the micro HDMI is type D. So on the USB, right, and the HDMI, right, the connector, the big connector is the type A. Okay. Now on the smaller HDMI, the connector that will be type C and type B. So often they would refer to HDMI type C or mini HDMI. So if you're looking for a mini HDMI, right, you simply go on Amazon and you type that in. And it is different in size compared to the micro HDMI. And where do you find mini HDMI? Some television has it. I know my Raspberry Pi, on the new Raspberry Pi, it has it. So the Raspberry Pi is a small micro board. It is a computer that you would insert the SD card, and then you can run an OS on it. So you can make it into a computer, and all you simply need to do is to connect it to a screen. So you can see as a regular computer. So the 1.4 HDMI is the micro, where the 1.3 is the mini. So here's a picture of it, of different types. That's what we talked about before. So this is the DVI-I, okay? And you look at the pin inside the DVI-I, it's different than the pin in DVI-D. So when you look at the cable, if it's a missing pin in the middle, that's the DVI-D. Okay, if it has all the pins like this in 3 rows and 3 rows, then that would be the DVI-I. For number 3, we know that that's the HDMI. It has 19 pins. And then the mini HDMI, it's smaller than that, right? And it's still in the shape of like a flat D. Okay. Now the display port looks a little bit different. The difference between HDMI and the display port is the square edge on the right here. So it would have a curved edge on one side and the square edge on the other side. Okay. Whereas this one, it has the cutout on the edges. So it's not completely round, but it's grooved in. And then the mini display port looks like this. Okay. And just to be sure, you should always read the specification of your screen, or you can use the internet to search for that model. It gives you the spec on which port is available, which connection type should be used. So let's say that on my TV, I cannot use HDMI, but if it has mini HDMI, I can also use to connect using the cable. But often you would see that they would sell the converter like this, meaning that this is an adapter. We can convert regular HDMI to mini HDMI, let's say. Okay, so if the TV doesn't have the regular HDMI, but it has the mini, but you only have the cable, which is regular HDMI, then what you can do is you can buy the adapter, the converter, to connect it, so that way you can adapt your regular HDMI cable to the TV. Okay. Any question with this? Okay. So we saw some of this already in the other picture, but this is a video adapter, a video card that would have HDMI, VGA, and DVI. And often you see that. This is a little older. Now you often see on a higher end video adapter, you would see HDMI, right? Maybe mini HDMI or micro HDMI, and then a display port. Okay. So let's talk about DisplayPort real quick. DisplayPort been around for a long time. It was used by Apple first, just like Thunderbolt, and then it was later integrated for PC. Maybe 1 second. So with the DisplayPort, you can have very high resolution. And often, if you're building like a gaming machine or a gaming computer, you would use the DisplayPort. Or if you're using VR, virtual reality system like Oculus Rift, you would use the DisplayPort. You can use HDMI, but DisplayPort will give you higher output. So here it talks about DisplayPort and how that's different with HDMI. So DisplayPort has 20 pins, and that's the name of the connector, DisplayPort, one word. There's also a 20 pin And as you can see, all cable, what it does is it draws power or it distributes power. So we use 3.3 volt, and that's pretty standard for all connection type is 3.3 volts. We can have it go up to 15 meter long. So in the case if you're using Oculus Rift, you're connecting your virtual reality system to your computer and you're looking into the goggle, right? You can obtain a longer cable so that way you can move around when you're playing game on your virtual reality system. So distance-wise, display cable is very good. Okay. So there's different grade or versions. There's DisplayPort 1.1. Here's the through transfer rate, 8.64 gigabit per second. Okay. So it's different between 1.1 and 1.2. You have higher transfer rate, and that's often used for 3D. So it's important that you read the specification when you buy video adapter or system that has DisplayPort. Okay. The 1.3 has 32.4 gigabit per second, and it's used for 4K and up. So if your TV has a display port or your monitor has a display port, and if you want to output 4K, 5K, or 8K, you need to obtain the cable for this version 1.3. A lot of people don't know that. They just go buy a display cable and it doesn't work. So make sure we know the difference. And in troubleshooting, we have to understand this so that way we know what type of cable we need to connect to make things working again. Okay. Any question as far as display? Okay, so I'm going to switch over to the assignment. I'm going to go over the first couple of questions with you. So for number one, it asks you to identify the video connectors in the image. And what you see on the left is a video card or a video adapter. This is used to convert signal, right, from the system so that way it can be displayed on screen. So now, if you look at the connection, one should be VGA, and this is the female, right? So the cable you use would be a male. Two is a HDMI. Three is a DVI. Let me double check that one second. That's right. Sorry. Okay. So that will be a DVI-I. Now on the right hand side is an older video card or video adapter. And this one also has a VGA, a DVI-I. But number 4 right here is an S video. That's round and it would have a rectangular pin in the middle. So going back to the 90s, this was often used for video. It came with some of the Nintendo PlayStation. It came with many different systems that needs to be connected to television or screen. So that would call an S video. So when you see that on a video card, you would know that that's an S video. So this is older. Okay. Now for HDMI that we would use for the 1080p, meaning that that's the pixel size for that monitor, that would be commonly used for that type of monitor, that would be version 1.4b. Now in general in the market, they would sell the latest version, right? But just to make sure, you want to refer to manual for the screen, so that way you can buy the appropriate cable. Any question? So answer number 1, list the port. We did that. And then for number 2, we know that this is version 1.4b. Okay, next we touched on these already, so I want to go over number 3. So these are different types of HDMI. For the 1, that's the standard HDMI type A. Remember, this is the larger connector, so it's type A. Okay. So this is your regular HDMI, 19 or 20 pin. The second one, let me move this down so you can see it together. The second one is your HDMI type C, which is a mini. And notice the size difference, right? Approximately 50% in size. Then number 3, which is a lot smaller, that will be your type D, your micro HDMI. And people often mix up the two between the mini and the micro. I see that a lot. Because they would intend to buy the micro, but they purchase the mini cable, which they cannot use, and so forth. So make sure that you know the difference. They're drastically different in size. Okay, so 1 is your standard HDMI, that's type A. Remember, that's the first one that came to the market. 2 is HDMI type C, that's a mini. And 3 is HDMI type B, that's a micro. Now going back to this, right, most of the time the connector would have the protector, which it protects the housing of the pin. But the cable itself, it would wrap the copper, which is used to transfer signal between your computer and the screen. Any question? Okay. Next, we're going to talk about display port for number 4. And as I mentioned earlier, display port is slightly different in HDMI in the fact that it has the square edge on one side and the cutout edge on the other. It's intended to be this way, so that way it's easy to install. Now for the first one, this is the common, your standard display port connector. This is the first and number 2. If you're looking at the mini, different in size, definitely smaller. And the second one is the mini display connector. So if you look at the video card, one video card is, let's say, $200 and it has a display port. The other video card, that's $150 and it doesn't have the display port. It only has HDMI and some older ports. Then you also need to take a look at what is the storage capacity for that video card and the processor. So you often see that DisplayPort is equipped with the higher end video adapter because it's intended to use with higher definition display. So that is an example of the different types in the video card. Any question with number 4? So after this, yes.
Oh, no, that's fine.
Okay. So after this class, I hope that you can be able to identify different ports when you see it, understand the difference when you troubleshoot connection. You can start looking at the type of cable, specific connection point. Okay. I will go ahead and start number 5. So we touched a little bit on this last week. We talked about different types of USB, and I want to give you a little bit more review doing this. Okay. So in number 5, it starts with 1 is your USB, and this is the symbol for USB. We're familiar with that. So this is USB 2.0. That's an older version of USB. And in the second one, this is USB Type-C. This is a picture of the Apple computer. So that's also the Thunderbolt. And it looks like the Thunderbolt symbol there, right? So this is a Thunderbolt 3. So in PC world, we would refer to that as a Type-C. In Apple world, they would refer to that as a Thunderbolt 3. And there's different type of Type-C. So some of them are able to have power with USB, meaning that you can charge with that USB. In smartphone, you often see that. And then there are some systems that only take Type-C for data transfer, no power capability. Any question?
Yeah, I wanted to ask, sometimes it says USB type A 2.0 and 3.0.
Yes.
What does it?
So the 3.0 gives you higher output or transfer rate. And the 2.0 came before, so different data transfer rate. So you want to go with 3.0 for higher data transfer rate. Okay?
Okay, thank you.
Yeah, you're welcome.
Question.
Yes.
I guess when you plug the 3.0 into the 2.0, are there different behaviors or it just doesn't run when you put a USB flash drive?
So it should, if you plug in the 2.0 into the 3.0, so 3.0 USB flash drive should be able to run on 2.0 because of backward compatibility. And then if you plug the 2.0 USB into 3.0, it should be able to read because of backward compatibility. They design it that way. If it doesn't run, it could be the firmware for that USB flash drive itself. So I would, and USB flash drive goes bad, that happens. So you want to make sure that you check if you plug in a different USB flash drive and it reads, that means that the first flash drive is broken. Okay.
And on Windows computer, sometimes it, that message pops up where they like to check the USB drive for errors.
Yeah, sometimes that would also wipe out your drive data because it wants to format. It does see some issues, right? Could be file allocation issues. And that happened to me a couple of times, right? When you're trying to repair the USB and then it ended up wiping out the data because it wants to format it. So Windows, it's gonna try if so. Let all USB drive comes with FAT32 or lower file system. Every operating system have different file system structure. It's kind of like every brand of car have different motor, right? Like a Ford compared to a Toyota or a Chevy, etc. Okay. So what happened is when you use a USB drive in different type of system like Mac OS and you store, let's say, pictures and things, technically that USB drive should be able to adapt to any OS if it's formatted with FAT, F-A-T, file allocation table. And that comes standard out of the box. However, sometimes when system write files to the drive, right, it wants to add, right, tags and indexes that would refer to that system. So when different OS is used to open up that drive, it's going to see that as an issue. So it's going to want to say, I want to format it to my system. So that's what Windows is trying to do. And we'll get into file system and OS next week. I know it moves a little bit fast, this type of class, but I have to make sure that I cover more than 80% of what is needed for you to understand how to troubleshoot computer.
Well, thank you.
Yeah, you're welcome. So be careful when you click yes, because Microsoft was going to try to format it to its own file system and then it wipes out the other file. Okay. But we'll talk about drive and how to fix some of the files on the drive in different OSs. So for 6, you should know that we can plug up to 127 devices through hubs and, daisy chain of hubs, meaning that I have one port on my computer and I can buy a hub which uses that USB and I can plug in 4 more devices to it. And then I can plug in another hub to that hub and I can daisy chain it out. So I can end up with 100 and something devices. But remember that when you have that many devices going back to one connection, it's going to be very, very slow. Okay. So let's say that I plug in 20 devices using the hub to that one USB port on my computer. It will recognize it. However, if you have to funnel out from one point into multiple points, let's say I'm trying to save data on these flash drives that I'm connecting, 20 flash drives that I'm connecting to that one USB connection through the hub, it's going to be extremely slow. It's very much like, how when you're in traffic, right? California, you should know this. Caltrans put the sign saying that all 5 lanes is going to merge back into one. Okay, so we're going to merge all of these devices back to one path. And what will happen is it's going to slow down the traffic, right? So when you're accessing multiple devices from one connection point using USB hub, it's definitely going to be slower. So keep that in mind. Okay. Any question? So let me go back to our notes and then I'll talk about a little bit more about Thunderbolt. So Thunderbolt originally also was Apple integration, and what the industry saw was that it was such a advanced technology that they want to incorporate it. So some manufacturer incorporated Thunderbolt into, you know, their adapter and their motherboard. And as you can see now that we have USB Type-C, which is, you know, a version of Thunderbolt 3, and Apple was the first one that incorporated that. So in the old iPhone, what you saw is you saw that they had adapted that as a charging point, the charging port for the iPhone, and then they adapted that for the iPad. So those connectors are 30 pins. In 2012, the 8-pin reversible was released. And this is the flat one with, you know, with the gold pins on the top. You saw those. And those were approximately like iPhone 4, iPhone 5 era. And then going into the 6, they changed that up again. So as you can see, we improve over time because every time that we improve the version, it's either twice or 4 times or 8 times faster. So when you're looking at USB 2.0 compared to 3.0, definitely drastically faster. It's kind of like going from a bicycle to a car, like a slow car, right? And then from there, we can go to a speed racing sport car. So as we improve our transmission media, our connection media, we improve the way we transfer our data, we improve how fast it's going to be to communicate with our system. Okay? So when we went from 3.0 to 3.1, which is not that far apart in generation 2, which is what you see currently, 3.1, they don't call it 3.0 anymore, they stop at 3.1, is that you see that it's 4 times as fast compared to what you see in the earlier USB like 2.0, which was a stable version, and it was used for a long time. It's still being used today. So Thunderbolt been around for a while, and they improved the technology. The newest version of Thunderbolt is 3, and that's comparable to USB Type-C. So I have 2 laptops that I can use USB Type-C to transfer data and to charge. But it also uses a regular AC round connector to charge as well. So they give you multiple options to charge your mobile devices now. So there's the spec on page 6. A table gives you different speed as far as Thunderbolt 1, 2, and 3. So if you use Apple product, this is important, right? So the latest Apple product should come with Thunderbolt 3, which is 40 gigabit per second. And then the earlier ones, like we talked about the old iPhone, that's 10 gigabit per second. And that we're looking at, you know, the average transfer rate. Actually, they test it with the lowest, so they don't give you the average spec there. So it on the low performance end, that's what you would see. So 40 gigabit per second, and then the length of the cable is important, right? 3 meter max. And the farther you are from any source in any form of cable, especially when we're using copper, is you would have latency, which is it slows down, right? So the farther you are from the source, the slower it will be. And also you might have interference. So when you put it around a lot of different type of cable, because electrical signal, right, interfere, just like how you have you know, speaker that make the pitchy, you know, whiny noise whenever you have your smartphone near it. So there's some cross signal and that creates interference. So just like, you know, how you run a long hose and you turn on your water, at the end of that hose at, let's say 50 feet, it's going to be very low compared to if you have a shorter hose and you turn on the water, it's going to flow a lot quicker. So that's just the rule, right? But we should have up to 9.8 feet or 3 meters. So here gives you some additional picture. I'm a very visual person, so when I learn, I like to look at pictures, or I like to use diagram and graph out things. So, but it's good to identify these physically on what they are and how are they different. Okay. So this is what you often see, right, as a docking station. Like we're talking about laptop or mobile devices dock that you would purchase from Dell or HP or, you know, a company that you would use, and the company organization, they would use this to support mobile workers. So we have Ethernet connection that allows the system to connect to the network. Then we would have USB, so that way they can transfer data or charge, right? Then we would also have Thunderbolt, so that way they can transfer data quicker or charge. And then HDMI, so they can connect things to screen or sound system. And then we would also have the DC, which is for power. So DC, this allows it to convert to electrical signal for indoor home or business use. So the AC jack would connect to the DC connection. That would convert it to DC signal there. Okay, so on the next page, which is page 7, it goes over USB a little bit more. I touch on the USB-C. So I have a cable here, and this is a USB Type-C. So the big end is the Type A. So that's why they call it USB-A. And the C, the smaller end, that is the Type-C. So when you're looking at the cable, like the cable that's connecting to your printer, or the cable that's connecting to other devices at home, right? Like your camera system or whatever it is, you're gonna have the large end. This goes to your computer or your system, or it could be electrical source, like your adapter to the outlet. And then this end goes to the device, the smaller end. Okay, so, and some of them are Type B, but in this case, I have a Type C and a Type A. Okay. So Type C is capable of transmission power and data versus the older USB, right? It does, you know, you can use either for data and then you can also use for power separately, but it does both for Type C. And it is reversible, so we don't have to worry about plugging it in backwards. That's the cool part about Type C. I like it a lot. Okay, so here, there was some question earlier. What's the difference between 2.0 and 3.0 outside of the fact that on the connector itself or on the connection point, the port, you would see that there's a blue, right? The blue part that to show, it has a blue mark to show that that's a 3.0. And 3.0 stands for super speed. And then 3.1 is a super speed generation 1. 2.0 is high speed. So we mentioned that we can plug up to 127 devices using hubs, right, and daisy chain. So there are two types of generic USB. There's a bus powered, meaning that it needs to connect to the computer, okay, to obtain power. Like for example, I would connect my webcam to my computer and it draws power through my computer. Now, if it's self-powered, then it can get its own power source through the outlet. So when you're charging your phone, right, that would be a self-powered. But now if I take my phone and I plug it into my computer, then it is also bus powered. Okay, so but there are specific type with USB cable sometimes, but most cable now they're capable of doing both bus and self-powered. In the past there wasn't, but now you see more common that cables are capable of doing both. Any question between USB 2.0 and 3.0? So here shows the picture, and as you can see, 3.0 has the blue inside for the connection, where 2.0 is either white or black. Not all 3.0 would have that, but that's a standard practice for all manufacturers. So let's touch on these, the difference between these, and then we can start labeling them. So often you would see these, could be on printers, could be on other devices. So the 3.0, let me go back. So this is on the left side, this is the 3.0B. So this is the cable and it plugs into this connection. Where on the right side, this is the micro B. This is the cable and it's gonna go into this connection. Okay, so this is a male, this is a female. Okay. So this is a micro B and this is the standard B. So again, this is a type A, 3.0, type C. Now for 3, it shows you this, even though it's red, right? And on the 3.0, if you look where the pin meets, it's actually a little thicker than the 2.0. It's the way that they designed that port. Physically, it's slightly thicker. But it should fit in general if you plug in a 2.0 USB into the 3. Technically now they make it adaptable and you know, it should be able to have backward compatibility. So in the past, now if you trying to use the older technology like 1.0, that might not work. 1.1. So again, here are some of the differences between the USB connection with the type. So for our assignment, you can also refer to page 11, page 10, page 11. So I'm going to go ahead and help you with those questions. For number 7, let's go through from left to right. For number 1, that's a USB 3.1 type C. Round edges, type Number 2, this is a USB 2.0 type A. Rectangular, larger end, that's a type A. And it's a 2.0 because it's white right here on the inside where the pin sits. Number 3, this is a USB 3.0 type A because it's blue. Number 4 is USB 2.0 micro B. So it looks like a flatter D, and it has a rectangular cut out inside where the pin actually is housed. Okay. Where compared to type C has all round edges. This one has a flat edge on one side and round edge on the other. And that's the micro B. So they found that a lot of the devices using this, has issue with the connection because it's flimsy. So what they did was they incorporated this piece in the back to add to it, and then they updated the generation for that. So that will be number 5 is USB 3.1 micro B.
And what devices would you see number 5? I haven't seen.
I have quite a few devices. External hard drive uses that. If you buy like external hard drive, you often see that it comes with the cable for 3.1 like that.
Okay, thank you.
Yep. The 6 is older, so this is like the BlackBerry era, like going back maybe 10 years. 6 is USB 2.0 mini B. So many things to remember, right? Mini, micro, but 6 is USB 2.0 mini B. For number 7 is USB 2.0 type B, and I put down that you often see this with printer or larger electronics. Why do we know it's 2.0? Because right here it's either black or white. So when you look at your printer cable at home, if it's white or black on the inside like that, that's 2.0. And then the 3.1 is 8, and that is because here it has different pin size on the inside, but for us quickly we can identify it using the blue housing around the pin, and that's often used for printer or larger electronics. And they rate in, it could be varied in volts, but in general on the larger electronics require more power draw, so you often see that they use different pin sizes, physical cable sizes, and connector for that reason. I'll leave it there for a minute. Do you have any questions for me? So if you study for the A+, they expect you to know the differences. But for us, if you don't want to pursue the A+, we can understand the differences so that way we can troubleshoot our system, purchase the appropriate cable for our devices, use the correct connection, understand that they're different speed and such. Any questions? Okay. So I'll switch over back to the notes. And then I'll go through a few more things before we get into hardware, which is the next hour. So on page 12 at the beginning, it shows you a picture of gigabit Ethernet on one end and a USB on the other end. So this is what we have as an adapter. So for example, if you're trying to connect your system to the network, but your system doesn't have a working Ethernet adapter, then you can buy an adapter like this. Knowing that based on transfer rate, gigabit is very fast, and converting it back to USB, it's going to slow it down. So it's very much like going from a super speed highway lane into a lane that has a bunch of speed bumps on it where we drastically slow down. However, it will work, right? So you would basically dilute the signal down to something that's going to be a lot less, but it will be able to transfer still. So make sure that you understand that when we're adapting signal, when we're converting from one to the other, we're going to lose some of the transfer rates strength in from one end to the other end. Important thing that you need to know whenever you see the word serial in computer, that means that it flows in one line. Okay, so let's think about it. Let's say that you go to the DMV and there are 100 people in the parking lot, and then these people need to form a line to get into the DMV, right? So instead of going through the door with 5 people at a time, they are only going to send one individual each time through the door. What will happen is it's going to slow down the flow. So whenever you see the word serial, it just means that all the data bits get lined up and they're going to flow one after the other. So drastically slow down based on that connection compared to something that we can send simultaneously at a certain length, like 16 bits, 8 bits. So if we can send 8 people through that line each time, definitely we can take care of 100 people in a quicker, shorter span of time compared to if we send one person after the other, right? Now, all serial cable convert to RS-232 standard, and you often see this on printers. Now, the word USB has serial inside its name, Universal Serial Bus. So what they did was they converted the original serial cable, which is the RS-232, to USB. So that way we can still transfer data at a higher rate, but in each piece, we are able to group up the bits, right, in groups and be able to send it compared to what we see in the past when we only do one bit at a time. My other analogy for this is, let's say you have a bucket and you need to fill up that bucket with water and you turn on the faucet. One way is we're going to collect one drop of water after the next until that bucket is full. It's going to take us a very long time. Or the other way is that we're able to collect 16 drops of water or higher, 32 drops of water each time, right? So we would fill up that bucket definitely quicker than one drop each time. Okay? Any question? Okay, so now what we're going to do is we're going to get into the hardware section where we're going to touch on the cable, and then we're going to go into the hardware chapter where we talk about hard drive again, right? I actually bought a processor, some motherboard, and some component yesterday because I intend to build another system. So I got a Ryzen 5. So hopefully if I can't demo it today, I can at least show you one of the system that I had, purchased the equipment for, and I had my student at College in the Desert build it, and then I can at least sit the motherboard into the new case and you can see. Because I want to spend a little bit of time to do cable management, but altogether it's not a hardcore gaming system, but it is pretty beefy. Maybe 32 gig of RAM, Ryzen 5 processor with, micro ATX motherboard. So we'll talk about different type of components that will go into a desktop, and then I can share with you the spec. Okay, so serial ATA is the common cable that you would see, and this type of drive would take the L shape. We touch on a little bit of this when we look at the laptop. So the L shape, let me switch cameras so I can show you possibly connection. So let me get around my table real quick so I can show you. Hopefully you can see. So what I did was I removed the screw from the back of the case already, and they're pretty much just to screw. Some case you will have to use the screwdriver to open. And so let me turn my laptop around so I can see too. Okay. So in this case, we have various components, but what we want to do is we want to look at the type of cable that would go into the hard drive. And often we would want to do the management of the cable from the other side of the case. Now, how do I know where to really open up the desktop case? When you look in the back of your computer, when you see these ports that are connecting to the external devices, the opening of the case is always the opposite of that, okay, of the ports. Now, to do cable management, you would hide all the cable on this side of the case where the ports would be. Okay, so here is the inside of the system. So on the top right here, let me see if I can get it close. This is your heat sink, and underneath this would be your processor. Next to it is RAM. These two modules are RAM. Right here, here is the video adapter. That's going to connect to the computer via HDMI or DVI cable. This connection right here is for the power supply, and you would look at the cable, they would have color wires. Each of the color would indicate different electrical signal size. So the HDMI connection, you would see, if I can get closer, they are the blue ones right here, and they are in the L shape. So on this motherboard, we have 6 HDMI connections. So I have one cable that's installed right here.
Does that mean that you can connect 6 monitors?
No, I can connect 6 hard drive.
Hard drive. Okay. Sorry.
Yeah, so I'm sorry. The SATA, I meant SATA. I don't know why I said HDMI. SATA connection, there would be 6 SATA connection, and then on the back of my computer, you would see that it would have, so I'll show you the back. Let me see if it's at a better angle. So you see my video card right there, this one. So this one has one HDMI, a VGA, and a DVI. Okay. Any question? So now, just real quick on side notes. These cables right here, they are header cables for the case. It allows us to use the power button along with plugging the USB on the top of the case. So you have to make sure that those cables are connected to the power source through the motherboard, otherwise your USB and your power button will not work on your case. Sorry about my dog. Okay. So now, if you look on the bottom, this is the power supply. And its job is to draw power from your connection from the outlet or your surge protector and distribute it to the motherboard. The motherboard, we would plug in all the components. Did you have a question?
Yes. This is about the if you upgrade the CPU and
Yes.
it needs, say it's like a 10 or 20 watt increase in power, can you
Yes.
get away with not upgrading the power supply if it's like 10 or 20 watts?
If it's 10 or 20, it depends on your power supply. If you are 10, 20 watts over, and if you are at 70 to 80% usage from that power supply, then you don't need to upgrade power supply. So the way that you can calculate this is you would take a look at your processor wattage, your motherboard wattage, your drive wattage, and if you're using a video card, you would include that too. And that should take up 70% of the rated power supply. So if I add everything up and it's equal to 300 watts, then if I use 400 watts power supply, then you should be okay. But if you're using a 350 watts power supply, you're running close. It's a little tight. Okay. Yeah. So add up all your major components, and those wattage should be less than 70 or at 70% of your power supply wattage. Okay. So the cable header for the USB, as I mentioned before, it's the blue one right here. That connects to the motherboard. So when we plug the USB in on the case, we would be able to read the content of that USB. Then the white cable is used for, these are header cable. They're used to connect my audio, my power button. And then the hard drive for this is mounted in the back of the case, because all the new cases, it has a slot for your drive to be mounted, so you don't see them there. Okay. And this one was built approximately more than 3 years ago. I bought the parts and my students put it together. Any questions?
Hello?
Yes.
If the dust is like, it's caked on to the motherboard and you can't use a compressor fan to get it off, how would you get it off?
You can
Like it's so,
wipe. It's caked on.
yeah, it's so old. I bought it at a thrift store and the dust is so old that it's dried on there.
You can try using, I mean, alcohol generally is okay. Just you gotta make sure that you detach it from everything else. And then I found that water is a universal soluble liquid. So you can lightly clean it with maybe a Q-tip on the cakey part with water or alcohol, but make sure you get it completely dry before you plug it in.
Okay.
And I have rinsed stuff with water before and dry it, and it still works. So
Okay, thank you.
yep, you're welcome. Okay. Any question? Any other question? So I'm going to go back to screen share. So serial ATA is used for hard drive connection or optical drive connection. Optical drive means CD, DVD, Blu-ray. And it stands for advanced technology, but there's different grade in SATA or SATA. There's also ESATA. This was used for external hard drive. That's different than USB external hard drive. It's specifically made for external drives. So you would see eSATA. So the current version of SATA that's available in the market you often see is SATA 3 or eSATA 3. So when you buy your hard drive, it would say the type of SATA, and you need to look for the latest, which is 3, because that's a higher transfer rate. So here are the cables. As you see in my computer, we would have the angle-shaped SATA connection like this. So that's the type of cable. Oops. So the first one is, it's called the right angle SATA. And for the 3, it transfers at 6 gigabit per second. That's how fast your drive can be read or written. Now the older SATA is between 1.5 to 3 gigabit per second, and this is the older cable, serial ATA. So importantly, we need to know what type of serial ATA that we're using on the motherboard and on the drive, so we can use the appropriate cable. Most motherboard would supply a couple cable, or when you buy drives, they would come with cables sometimes, not always. But you need to read the specification to make sure that you're using the right cable and the drive is appropriate for your system with a certain transfer rate. Now the straight SATA, that's 6 gigabit per second, compared to number 1, this one doesn't have the right angle. This one is straight. That means I can plug it directly in. I don't have to angle it. So if I want to mount the drive internally inside the case, I would use the straight, where the angle one, it lets me pull the cable down and do more cable management and hide it to the back of the case. Okay. Here's the eSATA. Usually they would put the label on the protection of the cable connector. And it looks almost like the USB with the 2 holes. but the pin sizes are different. So going back to the 90s and earlier, we used a flat ribbon cable called IDE. It stands for Integrated Drive Electronics. So if you go get an old computer that has hard drive that connects with the flat ribbon, it looks like a flat ribbon, like this. I think I took a picture of it. Like that. Then that's an IDE drive. And notice that there's a missing pin. So there's 40 pins with the missing pin. So when you plug it in, you look for that missing pin and you line it up. Otherwise, you would bend the pin. So the challenge with the old drive is that a lot of the technicians, they're not careful and they would flip the cable upside down and they would ruin the drive by bending the pin. You see the pink edge on the right side of the cable here. Sometimes they're blue, sometimes they're pink, but it would have a color on the edge. And that color indicates that that is a pin 1 for the connection. So that's how the industry used to include the coding mark so that way we would know that that's lined up with pin 1. So when you plug this cable into the drive, look for the missing pin and line it up, okay? And the groove should sit in along with the middle groove here because it has a line that's going to go through those two parallel clip right there. Okay. So this is for IDE, or sometimes they would say extended IDE, EIDE drive. Any question as far as IDE, SATA? So let's answer question A. What are the differences between USB 3.1 Gen 1 and USB 3.2 Gen 2? It's that USB 3.1 Gen 2 supports USB Type-C, which has reversible connectors. Okay. Any questions? And the next question, it says list the types of hard drive cable. So we know that we can use SATA, which is serial ATA. For external hard drive, we can use eSATA. The older hard drive, we can use IDE. And lastly, even older than that, and it's still being used still on some very old server, it's called SCSI. So SCSI, we call that SCSI. And these drives need to be connected and terminated using daisy chain. So I'll talk a little bit more about this. You would rarely see this now, right? Compared to maybe 20 years ago, all the technicians used to work on SCSI because it's fast as far as performance for its time. It's often used in server systems or used for backup storage, etc. Kind of like your SSD today. Okay. SCSI, you can find it on page 14. It stands for Small Computer System Interface. And it looks like the ribbon cable. So if you need to incorporate or install SCSI into a system, the motherboard has to have that connection, just like all the other components, the other interface, right? It has to have SCSI connection. You can connect up to 15 devices, between 7 and 15 devices, and they're different class of SCSI or different version of SCSI. So one version you can connect 7 at once. Think about like how back then they needed 7 drives to be able to have backup of data, or you know, run it for different type of applications, whatnot. And then the later version of that allows 15 drives connection. So on the 15th drive, it needs to have a termination indicator, so it needs to switch it off. Because what happened is when it writes data, we can write it to the first drive, the second drive, the third drive, etc. But when it gets to the 15th drive, it needs to know that that's the ending drive, so the signal doesn't get sent around again. So this is what we call daisy chain. So another analogy for daisy chain is like this. You're trying to put up Christmas lights at your house, and you connect to one outlet using extension. And then from that extension, you connect other extension to it. And this becomes a fire hazard because, you know, when you have, let's say, 4 extension to one and that one extension to the outlet, what will happen is it's going to cause heat to that main extension, right? And that's how usually fire happens. We don't do that in technical world because daisy chaining electrical connection is dangerous. But in the case of SCSI, they made it to daisy chain so it can write to 7 drives simultaneously. Okay? So daisy chain is like how we talked about the hub connecting to hub, that will be daisy chaining. So on the SCSI drive, and you might find them still, looks like this. I threw away mine maybe a few years ago, or I recycled it because there's no system that I use now that requires SCSI drive. I wish I kept it so I can show it to my students. I donated a bunch of my old stuff to COD, and they keep it there to show their students. So I didn't take it back. Any question? So that's what SCSI cable would look like. And then we'll talk about RAM next. Okay, so we can have different types of adapters to convert signal, as we talked about earlier: HDMI, USB, Ethernet, right? Different type of video converter. So that way we can adapt old technology to new technology to old technology, and these are the type of adapters. And they can range from a few dollars to 20-something dollars. It all depends also on supply and demand, right? So when you're looking at like DVI, that is spacing out, or VGA, you might have to spend a little bit more than a couple of bucks to get the adapter. But if you're looking at HDMI, where it's a little bit more common, you tend to see that it's more affordable. So here are the description or the name for each. Let me get to the RAM section. Actually, I want to go over this real quick, connectors. So some of the top connectors here, it's important for people who get into networking to learn, what it is. And in networks, we might have to make cable, install equipment that use those cable. So the RJ11 is your telephone line. This is your telephone jack to the wall that uses that connector. So it has It's usually clear, right? And it has a tail clip on the bottom. It's small, it's like the size of your pinky. The RJ45 is larger. That's for Ethernet. And if you look at your connection on your computer or where you plug in your computer to your router at home, sometimes some home would have the jack that would have Ethernet installed into the wall, right? That would be the RJ45. We talked about the RS232 already. That's for the older printers, serial type of system, old mouse. B and C, this is your coaxial. So when you call Spectrum or Frontier, they come and they install your internet or your cable TV. This is the round cable that would have a needle in the middle. And we would use F connector with the B and C. When I teach networking classes or CIS824A, I actually make the students make the cable so that way they know how. And it's pretty fun. You get a working cable you can use. But unfortunately, COVID, we don't have access to that from the school, so we will probably have to demo it. So the RG59 and the RG6 is used for coaxial. And as you see, it's actually for different purposes. For CCTV, and then in some cases for just cable TV. And it uses a special punch tool. It's not difficult to make. You can make one in a few minutes. And they do sell the kit at like your home improvement store. We already talked about the USB, so I just want to touch on some of those so to give you a better understanding of what they are. Oh, and Molex is your power supply. So when you look at your power supply, you often see that they have these plastic clear or white connector that would be connecting to either drives, components like your video card or your motherboard or hard drive, right? Those are called Molex. And there are different sizes too. So in the computer world, there's a lot of different specification, and this takes time to remember, right? Like the first few times you read it, it might sound very strange, but as you use it, you start to be familiar with it, and you would know how many pins, what it looks like, what is it used for. Any question as far as cable? Okay, so let's get into the fun stuff, right? RAM. So we touched on SODIMM last week because we talked about laptop, but this week we're just going to talk about RAM as how it would use for desktop. So to install RAM, we want to use RAM that would be compatible for our system. That means that it needs to be compatible with our motherboard. The speed of it needs to be equal or higher to our current speed if we're upgrading. And there are different types. So RAM stands for random access memory, and all the storage is temporary, meaning that when you turn off the computer, all of that goes away. It flushes, right? So in order to retain, this is called volatile because in order to retain, it needs to have power. So RAM is not permanent. So some of the things that you need to look for when you're looking for replacement of RAM or upgrading of RAM. You need to look for form factor. We talked about the physical design, the size, and the layout of the RAM. That's very important. Okay. Type, DDR2, DDR3. We need to look at the memory speed, like the PC and the number, or sometimes they would give you a sticker and it will say something in megahertz. That will be important to know because that would tell you how fast that's going to be able to read and write. And then it also would indicate the CL value, which is address stroke. As it writes into the RAM, what it does, it creates a number for the location of that memory. So let's say that you're running an application like a game, you're playing a game, and when you run the application, what it will do is it would use the memory and it would generate a range of addresses for that application in order to give you the image that you see, right? Like the person using a certain weapon, running through the terrain to look for the enemy, right? So you would have a range of addresses, and the way that it would refer to those addresses with the timing to access those label of addresses is called the CL value. So it says that if you install memory module that uses different CIS or CL value, it may become unstable or it crash, and you would have memory error in your system or lockup. So a lot of the times when we run into issue as application lockup, right, especially on the older computer that's lacking RAM, is that you would see that it's slow, and also when you open up applications, sometimes it halts, okay? And all that goes back to how it's able to access the location of storage, right, on RAM. If it's running out, if it's low on RAM, it won't be able to write as fast as it could. So it has to overwrite, and it crashes. So I want to demonstrate real quick since I have you on. So here you see my computer. What I do is I clip, you can clip this. This is my wrist strap. I clip this to the case, and you can clip it to wherever you like here, right? So I'm going to go ahead and clip this. Now I have 2 modules of RAM here on this system. Notice that I install it, one on the outer channel right here on the outer slot, and then I skip the second one, and then I install on the next. So most motherboard, they would have a color code, and you want to pair these because they're dual channel. So what you need to know is that you need to pair them accordingly based on the slot as well, because they write across in parallel. So it can go from one module to the next, and it accesses the memory in dual channel. So in order to uninstall, and normally I would lay this down, but since I have to illustrate, you would pull the clip back, and then once it's back, the module automatically gets released, and it push up a little bit, and then you would take it out. So this is Anarchy PNY. I got this a while back. So this is a DDR3. Okay, that's the type. And on it, you would see the sticker. So on this one, it's 8 gigabyte. So 2 sticks is going to give you 16. And the speed of it, it says 1866. So it's not as fast as some of the later ones now, but it's a good one to practice on for my student. So that's what the sticker shows. So as you see here, this slot is color coded blue, and then next to it is black. So what we want to do is we want to pair them so that way they're matching as a dual channel. So we have this one is blue installed with the blue, so that will be 2 in pair. So when you install, you just gotta line up the gold pin, and then you insert the module, okay? And on the DDR3, on this one, it has a shorter cutout, the shorter pins on the top and a longer pin on the bottom. So you just match it up with the cutout on the slot. Once you insert it, push it in, and then pull the lever back to lock it into place. Any question?
If you want to add more into it, let's say a third one, is it okay to add a third one, just the third one, or do you have to do the pair and have all 4 of them installed?
You can just do one more, but ideally they recommend you do pair, because it's still gonna write to the third one, but if you can get both, even in smaller size, it's better, because it writes across the channel. If it
Sounds great, thank you.
Yeah, you're welcome. So if you have, let's say I have 16 gigabyte on this system right now, I can go buy 2 more sticks of 4 gig each. That's gonna give me another 8. Okay, so that is a total of 24 gigabyte. So now I went to Micro Center yesterday. I don't know if you know of Micro Center. There was a lot of traffic going there and back, but they had a good sale. And I picked up some stuff from Amazon, but Amazon does have some back orders, so I want to show you. So I picked up the new DDR4. This is the Crucial DDR4 16 gigabyte. That's going to go into the new system that I'm building. And then hopefully I can have that ready for you by next week. Maybe I can start it today to show you. And this is another pair from Patriot. So it doesn't have to be exactly matching brand. That will be nice, but I just picked up something that's on sale. So this one ran about $58 for 16 gig. And then this one was $60 for 16 gig. So originally it was 86 bucks, but they marked it down to 60 bucks yesterday, so I picked it up. So both of these are going to give me 32 gig for the new Ryzen system that I'm building. Okay. All right, any question regarding RAM? Okay, real quick, we talked about synchronous DRAM. It's syncing with the processor speed, and that is what we're using today, is the synchronous RAM DDR. So synchronous DRAM is synchronous dynamic RAM. It uses double data rate. So every time that you have a new DDR, it's doubling the previous one. So the DDR1 was at a certain rate. When you have DDR2, it doubles DDR1. DDR3 doubles DDR2, which quadruple DDR1. DDR4 doubles DDR3, quadruple DDR2, right? And it's 2 times quadruple DDR1. And they are in all different sizes. So here is some picture of different RAM. So single outline memory module, that's very old. So you're looking at a very old PC, I want to say early 90s. SIM and RIM were around, and then this is for laptop, micro DIMM, very rare, but for the old laptop. Here is the RIM. This one was short-lived. It didn't pick up because I think a lot of manufacturers found it more costly to produce, so that type was released for a while and then they changed to DIMM. 72-pin SODIMM was available. And so you have some different type of SO-DIMM back then. Now we just refer to the DDR to really specify the type as far as the pin size, so we can distinguish how many pins in each one. Okay. So this is a DDR compared to DDR2. And notice that the pin is the same, right? But the cutout for the pin is different. The SO-DIMM DDR, this is shorter up here, and then the DDR2, the shorter end is back here. So they're different. Now, when you're looking at the DDR2, it's the cutout for the pin connection. It's almost at the middle. It's not quite as close to the middle compared to the DDR, where the front is a little longer. So they changed the actual form factor, the layout of the connection pin location from one version to the next. So that's very important to know, because we want to line it up and match it when you install. So when you unplug it, right, before you take it off, take a picture, take it off, take a picture of the slot. Okay, before you go to the store and buy it, you can bring it. If you can't bring it, take a picture of the sticker, so that way you would know. So here's the difference between DDR, DDR2, DDR3, and DDR4. And you see that they're slightly, the cutout slightly different. Question?
Yes, question. Does it really matter whether I buy the RAM from like a company in the US versus China?
Sometimes, but most RAM is produced in China. Okay. It doesn't matter what brand you buy, like Patriot, Crucial. Some they are produced here, or they actually get assembled here, but the chip were made in China. Now, in some cases, you do have non-rated RAM, meaning that it will work in general, but it's just not rated yet, right? So they would sell it for a very affordable price. But if you can get the same thing from China that's cheaper, in general, it's good. Now, on the security side, there's some argument about, you know, when we're buying storage and equipment from China, it's questionable whether they install firmware on top of it or not, right? That was never really fully proven, because in some cases there is, and so in some cases there isn't. Everything we use in technology is generally produced in China, from your Apple phone to, you know, everything that you use to refrigerator parts and computer for the refrigerator. So in my opinion, right, make sure that it's rated. And yes, if you can find something like a good deal, you can purchase it and use it. There's nothing wrong with that.
Sorry, how did you say that you could know that it's rated?
It would say that it was regulated or not. Sometimes they don't say it on the website, but I had bought a power supply and also some RAM previously from a source in China, and it just says that it's non-rated, or it's non-standardized yet. So, you know, but things that you need to look for is that if it has ECC, error correction code, that helps it fix the error when it writes to the RAM, right? And then the specification, like the speed, it needs to match what you have or higher. And then the type, it needs to be the same type. But, you know, without the cover or with the cover looks nice, but you don't need it. Technically, it's just a module with chips on the back. But as long as it matches, you should be okay. Okay.
Okay.
Now, the challenge too is that if you ever go, before they used to have computer show where people sell these RAM, and those are non-refundable. But even when I went to Micro Center yesterday, they told me that most of the stuff is, you know, they only take it back within 2 weeks, And then when they take it back, they deduct, of course, reshelving fee, but they don't always, they can, reject the refund and all of these things. Processor, definitely no. They said that if once I open the processor and put it in, if I want to return it, I have to send it back to the manufacturer and they will send me a different one. It all depends on the store, but a lot of the times you don't get refund on a lot of the electrical stuff anyway. Amazon will take most stuff back because it's Amazon, or Costco will do that, but not all places will do. So yeah, you will take a risk, and if it's cheap and if it doesn't work, then you won't be able to get your money back right away, or if you might not ever even get your money back. All right, so I think I'm gonna give you guys a break, and then we'll come back. We'll touch a little bit more on motherboard, RAM, and all that stuff, so I can start diving into some hardware and show you a little bit more. And then we'll finish out some assignment and lab, okay? So let's take a 15-minute break. We're gonna come back at 2:10 because it's about 1:55 now. So if you want, you can put yourself on mute.
I'm so sorry. This is the interpreter. My computer froze. Did you say there was going to be
Break, yes.
break from what till what time?
2:10.
Okay, great. Thank you.
You're welcome. Okay, you have a question?
Yes, Professor, I have questions.
Yes.
If I replace my corrupted hard disk from 1 terabyte to 512 gigabyte, that would be okay.
Yes, that will be fine.
And then
So
once
you going from 500 gig to what? 3?
no, from 1 terabyte, from 1 terabyte, it's like lowered on my hard disk from 1 terabyte to 512 gigabyte.
It is okay if you don't transfer all the data over.
No, yeah.
Yeah. So yeah, you can upgrade it and run OS on it. If you don't transfer all your data. So
And then
yes.
okay, if I can still recover my Windows 10, Professor.
Yes, you can still run the Windows 10. If the old drive is still working, you still be able to create a recovery image. We'll go over that next week.
Okay, thanks, Professor.
Yeah, you're welcome. Okay, we'll go ahead and get started back again, right?
I have a question about last week.
Yes.
You mentioned the bed pin and on the CPU, and should one try to fix the bent pin, or how does that?
Yeah, so you can fix the bent pin by using either like I previously used a wire brush to brush it back to straight, or you can use like a small tweezer to put it back. If it's not broken off, likely that it should still be working. But in some cases, if it bent and break off, then that processor is no longer working. So on the processor, if you look at the processor, let me get a processor out to show you. There's a little triangle to indicate that is a pin 1, whether it's AMD or whether it's an AMD or the Intel. So if you look at the processor, there's a little triangle. Just gotta line it up with the triangle on the motherboard.
So if you put it back so that it's straight, I mean, how do you, and then suppose it wobbles when you try to put it into the socket, how would you know that?
Yeah, that means that it's loose. So you likely will have issues with that processor.
Like how would that error show up when you turn on your system?
It won't turn on at all. Without the processor, nothing works.
Okay.
Yeah. So real quick, I want to show you on a motherboard so you can see. So here is a motherboard. If you look closely, there's a triangle on the actual socket. And on the processor, whether it's AMD or Intel, in the back of the processor, once it's uninstalled, there's a little triangle. Sometimes they mark it at the top, sometimes they mark it on the bottom. So that would indicate pin 1. Okay, there's a little triangle on the actual slot right there. That tells me that that's a pin 1. On this board, it's pretty good because they actually label everything on the board itself. But to take out the processor, you simply lift this lever up. Okay, this is the lever. This is called zero insertion force, ZIF lever. That means that when you line it up, you don't have to push it down on the processor. You simply seat it lightly, and then if it fits, right, what you do is you lightly, gently kind of push it on the side to make sure that the pin falls into its place, and then you press down the lever and it should lock it in place. Okay, and then when I lift this up, right, I can simply take this out. Okay. And notice that this has been cleaned, so there's no thermal paste on it anymore. Okay, so that's how you can work with your motherboard and processor. Let me put it on my anti-static mat. So, okay, just going back to the RAM real quick. I'm gonna hit back to screen share here. So for 10, when we look at upgrade for RAM, we need to look at a few things. The memory type, we talk about that, whether it's DDR2, DDR3, DDR4. The form factor, how the gold pin matches up to the slot, the size. Now, in some cases, the module actually has a cover that might be too thick or too big, right? It might hit other components. So even though it looks nice, sometimes, you know, that might not work for your system. Then we need to look at speed, the PC and the number, make sure that it's equal or higher. The capacity, the size of that RAM, it would say 8 GB, 16 GB. So when we upgrade, we want to go higher, but remember, there's capacity limitation with different DDR. So for 16, they don't, the production for the DDR4, I know that you do see one module that's 32 gig, but some motherboard will only take one module with 16 GB, okay, for the DDR4. So if you want 32 gig, then you would have two card or two modules, 16 each on each gigabyte, 16 on each module. So it's best to really look at the motherboard information, and it will tell you the speed, the type of memory, and the capacity that it can handle, along with, you know, the number of slots that's available. So in the computer that you see in front of you there, this one has 4 slots. But on this motherboard, which is an Intel-based motherboard, it has 2. So in this case, if I want to upgrade, I have to go higher in capacity with each module. But when I have 4 slots, right, I can still go to higher capacity, but I can spread it out to all 4 slots. Like somebody asked a question earlier about adding the 3rd one. Sure, you can add the 3rd one, and then you can add the 4th one down the line. Okay. So those are the things we need to look at. Question? Okay, for 11, these are the type, just like how in your notes, right? So the first one is DDR. The second one is DDR2. The third one is DDR3. And the 4th one is DDR4. Sometimes this is difficult to distinguish, right? Most of the time. So you would refer to the sticker on the actual module. Now, let's say you got an old computer and that sticker is not there, but you would see the motherboard information. It will tell you the model and the brand on the board itself. So you can do a little bit of research online and you can find out what kind of RAM it takes. Or in an old laptop. Because sometimes generic RAM, like, you know, places that sell RAM, they don't put label on it. And most of the time, even though when you're buying from Crucial, Patriot, or some of the company like Kingston, they actually produce it by contracting it with another company to create the chips or the actual module, and then they package it and they would sell it. Western Digital, they do that. They buy a lot of their drive components from other people, smaller companies that are contracted, and then they package it and they would sell it. And then they produce some on their own, but you know, so you see that. So for 1 is DDR, 2 is DDR2, and 3 is DDR3, and 4 is DDR4. And notice the cutout is slightly different. the position of that cutout in the module. The side right here are where the clips are gonna go and lock in. So that looks a little bit different, but it also can be designed to based on, you know, how they design that, whether they have to cover. But importantly, we want to look at the cutout for the gold pins. And don't touch the gold pins. Try to handle it on the side when you install. So that's why these, they have the little cover so you can grab it. But if it doesn't, right? So in this case, when you, after you have sit it in, and then you can push it down and the lever automatically should press back, or you can push it back to lock it in place. Never force it, because if you force it, it's gonna, you know, most of the time it fits perfectly in the slot based on that type. So the type is very important. So between DDR3 and DDR4, in general, the improvement of this is that they increase the pin numbers on the actual module. They also improve the speed and the input and output clock rate. So that's how they were able to improve twice the performance from the previous version. Now, if you buy a DDR3L, right, that just means that it's lower in power consumption. Any question regarding 11 and 12? So let's power for 12. They increase the pin, improve speed, and I/O clock rate. So one of the things that we need to cover is error correction code and parity. So in the notes, it gives you more details as far as description for each one. You can go over those, especially if you're preparing for A+. Talks about different bit size for the bus. And also like DDR3, it'll say PC3 and then a number. Sometimes it'll just say PC, but you know, most manufacturers, they will put PC3 and then the number. That means that it's a speed. Okay. So going into the reliability of your module. So when, as I mentioned earlier, the dual channel is when you want to increase the RAM speed for efficient performance by using dual channel operation. And we want to match them, meaning that they have to be the same capacity, they have to be the same speed. So I cannot mismatch them. So if I'm buying two modules, they need to be exactly identical. Like let's say 8 GB each, and they have to be in the same speed to really optimize the capability of dual channel. Okay. Single channel, that means that it uses one slot and individually, so it writes it, it treats it as individual entity when it looks at the module. So in some cases, you know, like in a laptop, you only have one slot, and that one slot uses a single channel. In the newer laptops, you would have two slots, and likely that it would use dual channel to optimize the speed. So it writes back and forth on each of the card, each of the module. We talked about color coding, so make sure that it matches up. On this one, it has two red, and then the other one, the other ones are red and then two yellow, so you want to match them up. And sometimes they're separated, like one and then the next a different color, and then after that it's the matching pair. So like this one, I have two blue and two black, and they are separated. Some would have triple channel, and often you would see 3 slots, 3 socket, where you would install at least one of 3. So in that case, we can upgrade all 3, right? And on the triple channel, sometimes it would have 4 socket, but it uses 3 each time. The last socket would not be used. So parity is a way that we can check for error or non-parity, and sometimes you see this in memory description. With ECC, what it does is it actually corrects the error code when it reads or writes. So you want memory module that has ECC, and it might be a little tiny bit more, not that much more now, right? So ECC included with the memory module, you see that it is slightly higher in price compared to non-parity ECC. So what that does is it actually checks the bits. It does a checksum, and it's looking for a specific value. If there's an odd number of ones, because the computer writes 0 and 1s, then this is called odd parity. And if your data has even and it's looking for odd, so the original data is odd and what it's trying to write is even, then it generates an error. It's going to say it doesn't match. So with that, with the ECC, what it does is it adds that bit to correct it, so that way you would have the corrected data stored. Okay, so here it talks about that on how it would check it for parity, and then after it's receiving the error message, how it's able to replace that bit. Or if it has an extra bit, it will take away the extra bit to make it even to match. So with the ECC, we want ECC, and also it would be indicated in your BIOS. So when you start up your system, your computer looks at all the connected devices and it creates a list. This list is actually stored in basic input-output setup, where it would say, oh, this is the type of hard drive, this is the type of memory. And in Windows operating system, you would see this in device manager, but it's not in specific, right? Or system information. So BIOS keep track, right? It keeps track of your system components, so that way it acknowledges that this is what it's using in order to operate, and the software, which is the operating system, refers to that whenever it needs to, you know, store data or write or run application. So the best thing that we should get with memory is to have ECC feature. So here on page 25 gives you the step-by-step installing, but it is really straightforward. Pull the lever back, right? Insert, make sure that the pin matches up. Don't touch the gold pin, touch the side, insert it. Once it sits in that slot, like what I have here, right? Once you sit in that slot, you can secure it by locking back and make sure that it seats all the way. So now if it's not sitting all the way, then you won't be able to lock it into the lever goes into the notch on the side. Okay. So ideally I would lay that down on its back in order to do a lot of the installation, but I have to stand it up so you can see, because with the tripod I'm not able to angle it so that way you can see clearly. So here it gives you the basic step, and I encourage,
Yeah,
you know,
tell
yeah. Question?
Oh, your laptop looks low in battery.
Oh, yeah, it will. I still got a little bit more juice. I still have an hour and 38 minutes, so I'm good. Yeah, I will plug it in when it gets a little lower. Thank you. Okay. So don't force it. We talked about not forcing any component when we do the installation. So here it gives you the picture as well. So for your project, I'm okay with you upgrading memory. You don't have to do major overhaul on your project as far as installation. If you like, that's better, right? If you want to, some of you want to upgrade hard drive or replace a hard drive that you have, like a HDD to an SSD, that's awesome. Some of you just want to replace memory. Some of you maybe have a non-working computer now, right? And you're trying to find out what's wrong. So I would start with, you know, thinking about the last time it's running, how to troubleshoot that. If you inherit it from someone else, you have to really test it through. Plug it in. If it doesn't turn on, it could be a various things. So we'll talk about troubleshooting step next week when we go over some of the OS part on how to do data recovery and troubleshooting on the software side. Okay. So as far as the project goes, make sure that you get your part 1 submitted by next week. I extended it for another week, so it gives you this weekend or sometime this week to look at a system that you want to upgrade. And it doesn't have to be, you know, something that you're using now. It could be, you can see if a friend has a broken computer that you can help. Okay, and I did ask TSS, so I'm waiting for them to get back to me. So if they have computers and things that they are willing to loan us, right, I can see how they can check that out for you. Okay. Installing storage drive with the optical drive, we know CD, DVD, and Blu-ray. Most of the time you would see now in the modern current components are SATA, but you might have an old one, an old system that uses IDE. Okay. So there are different types of optical drive. So most of the time you would see CD and DVD using pits and lands. So think of pits and lands as little valleys and dips on how the data is stored using the laser, right? When you burn data onto a CD or DVD, it would burn in continuous spiral, and this is referred to as pits and land. And that's on the non-label side. So when you're looking at on top of the DVD and CD where they label, they put movie names or, you know, artist name or whatnot. On the opposite side, this is what you would see as data that's stored. So when it does write, it actually burns from middle and it's going outward. Okay, so you know, if you think about the record, which is older, right? It's going from the inside out, but on the CD, DVD, and optical drive, it burns from the middle and it goes outward, and it divides all the data into tracks. Not like track as in we see as track as song, but track as in how the data is continuous when it goes through the entire disk. Okay, so here it talks a little bit about optical drive. So for 13, we said comparing parity and ECC, which technology is recommended for maximum data safety? ECC, of course, because we want not just to detect the error, but to correct the error. Parity just detect the error. ECC would correct the error. Okay. So 13, we want ECC. For 14, the differences in the 3 types of the optical drive. Number 1, CD, the lowest in capacity of optical drive. It has the longest wavelength and it uses laser. There was a laser disc system, but that was made by Philips. That was short-lived, right? But CD uses laser. And if you look at you burning a CD, the capacity, the size of it is a lot less than a DVD or a Blu-ray. And it has the longest wavelength. On the DVD, it has higher capacity than the CD, but the wavelength is shorter than the CD. It uses red laser. It's still a laser, but it uses red laser. On the Blu-ray, which is what you see, a lot of movies are still being sold in Blu-ray because it has the highest capacity that would hold longer movies, longer media. It has shortest in wavelength, and it uses blue laser. So in this system, I don't have an optical drive installed. You can find one and buy one, right? And in the case, most new cases now, it has the front cover, but you know, you have to find a case that would have that slot because most people don't use optical drive anymore. It's becoming obsolete. You don't find laptop with optical drive anymore. So a way that we can adapt it is to buy the external optical drive, plugging it through USB and be able to read and write and burn CD and DVD. And I highly recommend having that as either an accessory or something that you would use for repair, because you never know, you might need to, you know, like a client would give you a DVD that would have movies or data and they want you to transfer it into their computer. So if you have the drive, then you can transfer it. Or you can have them, you know, you can tell them that you would back it up to a USB for them or put it on cloud. We use cloud to stream for a lot of, you know, sound and video. So we don't really use optical that much anymore. Any question as far as installing optical or the different types? So 2627, it talks about optical drive. Okay. CD, CD-RW, what are the different speed and length? And this is why you see a lot of like the more, you know, like dollar store, they would sometimes sell blank CDs or even not carry it as much anymore because people don't use it. So when I serviced back then, a lot of people would complain about, you know, scratch CD and DVD. I tell my students that my trick is toothpaste, or you can also wipe it with olive oil, because that would even out the surface, that would minimize some of the scratch. So if you have your favorite CD of music that you like, that you kept for a long time and it's scratched, right, you can see if you can resurface it using toothpaste. They did sell the resurfacing kit, but you know, some works and some didn't. You can also clean it and then put olive or some form of oil on it and kind of smooth it out, and usually that's kind of even out the gash or the scratch on the data side. And here it talks about DVD, plus R and minus R, the differences. So when you hear the minus R DL like this, that's a single side writable. It's non-erasable. So you can only write it once. You can only burn it once. The RW is rewritable. So that means that you can write data over it. You can erase the data on it and rewrite it, but it's slower when you rewrite. Now, the plus RW is similar to the minus RW, but it's not interchangeable. So if you're using the disk minus RW on the plus RW, it's not interchangeable as far as the disk. So that's why they sell in variations of different things. The super multi DVD drives, it reads all type of DVD, and that's what you want really for like the all-in-one device, is that we want to read CD along with DVD. So we want to do the super multi DVD drive. So if you buy that as an accessory, something that you use occasionally, I would recommend that to read CD and DVD. Okay. So to answer the next question, for 15, it says, what type of DVD drives can read all types of DVD and CD media that will be your super multi DVD drive. Any question? I might have to dig out one of my old laptop that would have a DVD or a CD burner on it, but I haven't installed one for a long time now. So it's just, you know, they don't make it as much anymore. So just like how cassette tape went away, right? Along with, you know, even if you're looking for something to play CD music outside of the car, like a radio with a CD player, it's harder to find now compared to, you know, 7-10 years ago. So okay, the next section, it talks about Blu-ray. It talks about different types of Blu-ray, what's recordable and not recordable. So drive speed is very important. We wanted to look at the drive speed, the capability of different type of drive like CD. It's 150 kilobit per second on average where it reads music, and then writing is different. So 150 kilobit per second, very slow. The DVD, faster. So the one time, that's the one time. So if it says 4 times, then it's 4 times that speed. And then Blu-ray, 1 time is equal to 4.8. So if you buy a Blu-ray drive that says 8 times, you take that value times 8. So you have, you know, the result would be your transfer rate. And so in most cases, it would read at a certain rate and then it would write at a lower rate. Like it would say it will read at 8 times and it will write at 4 times, or it will read at 12 times and it will write at 4 times, etc. Okay, let's talk about hard drive. We touched on this last week, different physical size, 3.5 and 2.5. 2.5 for laptop and 3.5 for desktop. Or you can also now use 2.5 for desktop. So I picked this up yesterday and it is fairly affordable for anything that's less than 500 gig. So this is a 240 gig Kingston. This is considered solid state drive, but it uses SATA connection. So I intend for this to be used as a backup drive for the newer system. And then this one is going to be for the main drive for the computer that I'm building for this class. So this is a 500 gig. This is the NVMe. So this is an M.2. It goes into the slot on the motherboard. So this is going to run the OS. And then this one is going to run the data. The Kingston is going to be for data. So you can do it this way, or I can even use this one for the main OS because 240 gig is plenty for just operating system and simple application. But when you start adding data, right, like videos and images and sound, like music, then you might want to add another drive. But on my laptop, my C drive is approximately 250 on a solid state, and then I have a backup drive on that. But it's still feasible and, you know, for general use. So you can definitely use something like this. So going back to Rochelle's question earlier, she asked if she can go from a 500 gig to 120 gig just for the operating system and simple application? The answer is yes. Okay, so we want solid state because it doesn't have moving parts. It gives you the best performance. And you can also adapt it to USB this way using the adapter. Now, some computer case would have a bay, so this is called a drive bay, where you would mount the drive and screw it in. But most computer case in the back, it would actually have, let me see if I can open this one up so you can see. It would have a slot so you can mount it to it. So on this one, let me unshare so I can. As you can see, there's the SanDisk. And in the back of the case, I can add another drive on the bottom, down here. And then we can simply run the cable. So the SATA cable, this is the data. The SATA cable goes to the back of the disk. And we want to give it power. So this is for the power. So the drive is going to need a data and a power. Okay. So on page 30 in your notes, it gives you the steps on how to install SSD. So if I want to install another one to here, like this one, what I would do is it comes with the screw. I would take it out of the package and I would mount it to the bottom of the case over here, where that drive would be. And then I would run the cable from the motherboard through this hole, and I would plug that into the back of my drive. So I need another power and another data cable. Okay. Yeah, this system could be better in cable management, but you know, they did it and that was their work. So yes, question?
So there's a limitation to how many hard drives you can add because of the number of cables?
Yeah, it's the number of slots on your motherboard. So on this one, camera so I can show you. Okay, so you see these right here? There are 4 slots. I mean 6 slots for SATA. For 6 connections, so I can have up to 6 drive. And not all motherboard would have 6. Some of them would have 4, some of them would have 12, some of them would have 3. It depends on the motherboard. But on the new OS, you can have your drive install as many OS on the same drive. It can only be one active each time, meaning that we can only boot to one OS each time.
But what about the power cable?
Yes, so if you have power supply that's capable of supporting all those drives, then you can scale out. If not, you have to upgrade power supply. Good question. So let's say I have a 300 watts power supply and I already used up 250 watts for, you know, motherboard, processor, and the main drive and video card. Then I would be concerned with the additional drives get added on if I add more than 2 on there. So, but you can always pick, you know, an upgrade to a different power supply. And between 500 to 600 watts, they're fairly affordable. So this one is 700 watts. And it costs about $65 for me. And this is a thermal tape. So on the newer system, if you're running the newer processor, and if you have a nice video card, you want it at least 600 and up, because the newer components require a little bit more power. Any other questions? So M.2 would go into the slot for itself like this. It doesn't go into the PCI Express slot like normal. So here is the motherboard again. This is the outside motherboard, the older motherboard. These slots down here are PCI slots. They are the older technology. This is used to connect peripheral devices. And peripheral devices are sound card. Like if I am a DJ and I want to record people singing so I can make tracks for my album, or I'm a music producer, let's say, I would get a sound capture card for that. And this one is for the Express, PCI Express. It's faster than the PCI. So think of these as a 4-way lane highway. And then these are the super raceway to send the cars down the road. So this is very fast. Sometimes they're located lower, depends on the form factor of the board. And then you might have other slots depending on, you know, the actual motherboard, but ultimately you want to use the Express because it's faster. So on the new motherboard, you might have multiple Express X16, meaning that it has 16 lanes versus 1 lane to send data. So data would transfer quicker. So these, what we refer to as bus, B-U-S. And all that is a connection channel to the motherboard. Think of it like veins and nerves of the motherboard. Okay. So, it says actually what type of SSD provides the fastest performance for your desktop PC. Currently, we would use an M.2. An M.2, it would have its own slot. Some motherboard, it would have a cover. So you need to take a look at the documentation of the motherboard. And it would be something like this. Okay. They're all different manufacturers that produce them now. They're fairly affordable now for 500 gig and 1 terabyte. Now the trim feature on the SSD, it's a way that it deallocated space used by deleted files and make it available for reuse. Because this is flash technology, even when you delete, in older technology too on HDD, when you delete files, they don't go away, right? Especially with flash, is that it keeps tag of that file. So on the SSD, it uses trim, and what trim does is that after your file's deleted, it used that space to add new files. So when you save new files, it's going to reuse that space. So it's a little bit more efficient for reusing the space for trim. So trim is located on page 32. I know the notes are like 60 something pages, but because I'm combining some of the chapter components so you can get a lot more from this class. So it's a lot of details. We touched on SSHD last week. It's a hybrid between solid state and hard disk drive. It's a little bit more affordable than the SSD, but it won't be like as good in performance as the SSD. NVE stands for non-volatile memory express. This is used in SSD for data transfer. So when you're looking at an NVE drive, right, it is not a physical form factor like the M2, but it's just a standard protocol that's used to transfer at a higher rate. So that's why it needs its own slot to plug in. And we touched on SATA with HHD last week. It's magnetic. It has a mechanism that spins the platter. There's limitation with that. So the RPM for the mid-level performance, you would see these in the market. I was tempted to buy one so I could install it on this one. So I have 3 types of drives. Maybe I'll get one. So the 7200 RPM is the mid-level performance. If you want to go on the higher end, go for the 10,000 RPM. You don't see those as an affordable price. I think we have a lot of supply in this range, 7200 RPM. And then on the lower end, you would see them as 5400 RPM. So when you're looking at HDD to replace your drive instead of an SSD, because it's very cheap, then you would look at, you know, like a terabyte for less, about 50 bucks or less. So you would see that they would generally come in 7200 RPM. Okay, so here's some illustration for that again. Cylinder, sector, and track. And generally it writes 512 megabyte per sector. So think of it like pieces of pie, and you would have stacks of different pies, and then to access your data, it would look at each piece. Okay, so a track is a complete circle right here, the cylinder, and then the sector is the smaller pieces on the pie, the actual pie platter. Any question as far as hard drive? Something important to note, cache size is essential, okay? Now some drive comes with 8 megabyte, 11 megabyte of cache drive. You want a decent size cache size on the drive. So what that does is it just holds the information for reuse. It's a little separate memory that would enable the CPU to revert to that in case it reads the information again. For example, let's say that you play a first-person shooter game, right? And you shut off your computer after an hour, you go do something, and then you come back to it and you rerun that game again on your computer to play. Using that cache, what it is it's saying that, oh, you're accessing the same application file, right? Reverting back to that user information, the character that you picked or the weapon that you chose. That cache is important for re-reference when you're reusing that application and reusing the file. So we want a good size for that. So the higher the number, the better. 8 and so it could go up to 8 GB, and of course prices will change. There will be a direct correlation with the price. Okay, I want to get through some of the drive information and then we'll get to motherboard. So flash memory in your USB or your SSD, it retains its content without power. That's what's nice about it. When compared to RAM, right? RAM, when we unplug or turn it off, there's no more retention of data. In flash memory, performance is better. There's no moving parts, so physically it's more durable. And flash memory is used for your phone, your smartphone in SD, your SD card or your micro SD, your digital camera, your digital media devices, camcorder, tablets, you know, you name it now, everything uses flash because it's affordable, it's good, it's durable. It's not 100% guarantee though. Flash USB or flash SD sometimes would break or be damaged. Okay, so here's different type of flash. Some very small, some would be mid-size, so there's a huge table for it. Now my A+ students for CompTIA A+, I tell them make sure that you know the differences because you might get questions on these. So if you're looking to take the A+, make sure you understand the differences between the types. A little bit on RAID, redundant array of independent disks. So to sum it up, RAID is we use RAID as in combining multiple disks so that way it can write across the drives. And you often see RAID to be used for backup data, especially for companies like transportation company, train, plane, bus. So when you're using airport terminal systems, a lot of the time you accessing, you know, database server to look up your ticket, right, your flight number, etc. And they have to make sure that that information, that data is retained and backed up, stored multiple times, redundant. That's why the name redundant array of disks. So if we rely on one drive, what happens is if that drive goes bad, we lose the data. So we have to utilize multiple drives, and in some cases, different type of RAID. If one drive goes bad, you can still access the data. So there's different RAID type, and you can use RAID for personal use as well, but it costs more because you have to buy multiple drives. And you can set it up on software level to look at your hard drive, your regular hard drives, 2 drives at least, as RAID. Some motherboard is capable of doing that, some not. So RAID 0, it just stripe across 2 drives. So you need 2 drives and it just write between the 2 drives. So if one drive failed, everything's gone. RAID 1, it takes a duplicate of one drive to another, and a lot of people, they like using RAID 1. So if I write file 1 on one drive, it copies it, the same file 1 on the second drive. It's called mirroring. RAID 5, you have to have 3 or more drives. And in the case if one drive goes bad, it still works. And then you have RAID 10, which is a combination of 1 and 0. There's a 6 and more, there are other RAID, but these are the common type. Any questions, RAID?
Yes. So you don't really use this for your laptop or desktop, right? This is like more for a business or a server?
I have friends and students use RAID for their desktop. You can, but Yes, ideally for business use. You can, if let's say that you have, home business that you need to back up data, RAID is a good way to make sure that your data is stored multiple times. But it costs physical hard drive and also, your electrical costs because you have to support the power usage of these drives. But yeah, data center, you often see that they use RAID. It's not the new technology, but it's still being used today. So yes, you can use it for personal if you set it up. And you would set it up through UEFI and BIOS. And then some drive, it actually comes with tools that you can make it into a RAID drive. So if you look at drives, you can start seeing, and then be able to set it up as RAID 1 and 0 or both. Okay, so that's a little bit of information about RAID. And then the firmware to support RAID would look like this. I previously had a computer that had RAID. Maybe I'll look at it again and see. So. But you can always cloud your data nowadays, so cloud cost is not too much. You can have it for free for most part with Google Drive. Oh, just side thing on the USB ejection. Make sure that you use the eject button. Yes, you can pull the USB off of the USB port, right? So if you plug in anything external, make sure you eject it safely because over time, if you don't, right, it put wear and tear on that drive. So, and it also put wear and tear on that port. So make sure that we eject it using the eject button on the operating system. On the Mac OS, you would use the Finder and then click the arrow next to the USB. So I put down the steps on how to do that with different OSs on page 40 to eject drive. Okay. Any questions as far as drive? It's a lot, I know, of information to give you in all in one sitting. However, right, 4 weeks, we gotta get everything covered. So I want to give you as much as I can. Okay, motherboard. Form factor is super important. The layout of the motherboard. So, and what do we mean? The size, right? Physical size. This is ATX. Now, sometimes you would see the micro ATX, which is shorter, smaller physically. Okay. Also where the chip sits, because there's form factor pertain to where that processor would be, where the memory would be. Sometimes you would see the processor down here. Okay. And then RAM also down here, because they found that if they restructure it, it might help increase with cooling, because the fan brings air in and it circulates it out. So really the form factor is important. So when you pick the motherboard, along with that, we would pick the case, how it's going to fit inside your case. So if you pick an ATX motherboard, you would want a case that would fit an ATX board. Okay. Because on the small little desktop compact case, like the Pico ITX, it won't fit the ATX board. Question?
If you bought a motherboard on the internet, like how would you know that it works without connecting everything?
2 ways that you can test it. You can probably test it with, well, you have to give it some power in order to work. So you have to plug the power supply into it, because motherboard don't work on its own. And then you have to go to it with, test it with the electrical tester. That's it. But I would plug the power supply in and, you know, at least the processor in. It will turn on without RAM, but it will start beeping like crazy. Yeah, your system will not be fully functional without RAM being plugged in. But yes, so when you buy it, you have to take a risk. But yeah, if it's, you know, in general, that's how we've got to give it power to see if it's seeing signal.
Okay, thank you.
You're welcome. Okay, so ATX, you saw a full-size ATX, and then they have a micro ATX, which is smaller. So compare that to, I think I picked up one yesterday. The micro ATX is a little bit shorter in size. And what we would have, so in this system right here that you see, that's a micro ATX. So when you're comparing the board size, even out of the box, it's definitely smaller. Okay. So that would fit, and in general, this case was made for the micro ATX. It also fit the ATX, but it's going to go down all the way to the bottom. So you see the smaller cases would fit the micro, and then the smaller would be the Pico, and then the tiny, like the Raspberry Pi, would be the Nano. So form factor is very important. Okay. So you see this right here. Now on the ATX, you would see that the processor is always going to be next. It's going to be parallel to the RAM slot. It's right next to each other. Just like this one processor, RAM. Okay. All right. So here gives you the details on what each slot is. Okay, so for 18, motherboard form factor, you have the ATX, you have the micro ATX, which is physically a little smaller. You have the Pico ATX, which is smaller than that, and then you have the Nano ATX, which is a lot less. Then they came out with the ITX. So when you see those people who sit at their desk and they have like their monitor on top of that tiny little box, right? Sorry, this should be Pico. You might see ITX and then Pico ITX, which is smaller desktop, and then even smaller than that than the Nano. So when you buy motherboard, it will tell you what form factor it is. If it jumps out and say this is an M ATX, you know it's a micro ATX, and it would fit into a certain case. All right, let's identify the components. I wanted to kind of do the lab at like about close to 3:30, and then you can do additional research on your own, but it's due next week. Okay, so here's the picture. Let me zoom out a little bit. Okay, so let's go through and identify each of these components. Okay. So in the back of the system, right, these you can put down ports or port cluster. So this is where we plug in all the external components. We talked about, you know, video cable earlier, USB, all of that. That's a port cluster. And that is always in the back, right, of our case. So we would want to mount that against the back of the case.
I have two screens. Can we unpin a video and then make this one bigger?
I'm sorry. Oh, yeah. As in unpin my video?
No. It shows like the actual physical computer, and then it shows your screen. I was hoping if you can take the computer screen off so we can just see the your computer screen.
Let me see if I'm capable of doing that.
Yeah, that's
So
better.
you-
Thank you.
Okay. So the first one is the port cluster. This is port cluster. This number 2 right here, the 2, is PCIe X4. So it is slower than the X16, but it is good to plug in like Ethernet adapter, Wi-Fi adapter, or sound card, additional sound card, or things that you would need to be able to add more components to your system. Okay. Then for number 3, over here, right near, so you have 2 of those, even though the picture looks kind of dark, 2 of number 2, and then number 3 is right below it, and 3 is the Express X16, and you would know that it is the X16 because it has a clip at the end of it. So compared to the 4 and the X4 and the X16, X16 is much faster. Think of it as 16 lanes to send data compared to 4 lanes that send the data. Like I can, okay. And then for number 4, that's where you install your CPU. That's your CPU socket. Number 5 is memory socket or DDR4 socket. You can put memory socket or memory slots. This is where we will install our RAM over here. And this one has dual channel. You can see 2 black and 2 blue. Most manufacturers will color code it for you now, so it's easy. Number 6, which is over here, that's when where you plug in your power supply. So ATX power connector. So your power supply connector is going to get plugged in here, and it would fit as the connector is, you know, the form factor of the connector. So you can't really turn it around; it won't fit. There will be a clip in the middle, so you insert that clip and it would click. And I'll show you right after this before we get into the lab. Okay. And then number 7 is USB 3.0 port header. Remember the blue cable I showed you earlier in that computer? This is where we would connect that cable, the USB header cable for our case. So when the user plug in the USB drive, they would be able to access that drive. So 7 is this one. That's the USB 3.0. And then for the 8 is the front facing SATA port. So this is where we plug in our hard drive. On this one, it sits on the side. So that one is for front facing SATA port. Meaning that we can mount it in the front of the case instead of the back of the case. If we mount it in the back of the case, we have to use the right angle cable to bring it to the back of the case. And then 9 is over here. That's for your USB 2.0 port header. So in some computer cases, it will have a 2.0 and a 3.0 on the case in the front or on top. Then we need to plug in those cables so that way the user plug in different type of USB and it will work.
I had a question on the number 8.
Mhm.
There, SATA ports, what? I mean, I know that's more technical term, but what is it?
It is used to connect hard drive.
Oh, the
SATA
hard.
hard.
Oh,
Yeah.
that's right. Okay, sorry. Thank you.
Yeah, no problem. So this one only has 3. It has 1, 2, 3. Some have more and others have 6 or 4, depends. Okay. For 10, we're going to go up a little bit. So for 10 is over here, right? And 10 is front panel cable header. So that's for our power button for the case, right? Audio, like when you plug in your earphones, microphone, or from the front of or top of the case, right? We gotta plug in the proper wiring, and you would refer to the manual for the motherboard in order to detect, right? Which one is for which. So when you press the button and if it doesn't turn on, that means that you didn't plug in the right header cable. So you have to plug those in order to use all the buttons on the case. And then 11 is the case fan header. So what do I mean by that? So for 11 is right here, this little white one right here. So somewhere in the middle, or somewhere on the motherboard, there would be that header cable for the fan, and that fan goes to the back of your case or the front of your case. Some of them will have more than one. You know how when you turn on your computer and the fan kicks in on the back, right? If you're using a desktop, well, that's where you plug in that fan. If that fan doesn't work, check that cable connection. Sometimes you would have a bad fan, and the noise, sometimes if it comes from the fan, it's because the bearing on the fan is going, or sometimes it just have a lot of dust. So you might want to clean it out and, put a little oil in the bearing. And then for number 12, which is a CMOS battery, remember we talked about how it looks like a watch battery, this little one right here. And that gives a little bit of power for the system, the chip, to retain information about connected devices. It's for your BIOS information. And it's called CMOS battery. Complementary metal oxide semiconductor battery. That one goes out maybe after 3-5 years, depending on how regularly you use your computer. If your clock on your OS is kind of wrong every time you turn it on, that's a sign of that battery going bad. It's losing time.
Can you say that again?
When you turn on your computer, and if it's the wrong time every time, the CMOS battery is going bad.
Oh, okay. Thank you.
You're welcome. And they cost a couple dollars. You can find them everywhere. So to take that out, you would use a flathead screwdriver, push back the clip, and it pops out. But if you break that clip, then you ruin the motherboard. So because without that battery, it's no BIOS. And so also you can reset password for the motherboard. You know how in BIOS it has password, without using the jumpers to use the battery. That's the old way. You can take the battery off for about a minute and then plug it back in, and then it resets the password if there's password in BIOS. I'm not talking about password in OS, password in BIOS. So when you boot, you go to the setup, and if there's password in setup, okay, Now, password and OS, it depends on the OS, and there are different tools for that, but that's another session. Okay, any question? We're good with this, number 19? And you can refer to your notes. It has similar board on there. Okay. Question 20. It says, what is the primary difference between PCI and PCI-X bus? So the PCI-X is 64-bit, which is much faster than the PCI bus. Older, could be 16-bit. Okay. So think of it like we can transfer 64-bit compared to 16-bit each time. That's much better. Okay. Now the transfer rate for the latest SATA connection for your hard drive is 6 gigabit per second SATA 3. And it does roughly around there, sometimes slower. Okay, depends. So
This is the interpreter. My sound cut out. Do you mind? Could you just repeat what you're just saying? You're saying the transfer rate. What was right after that?
Transfer rate for SATA for your hard drive is 6 gigabit per second for SATA 3. Sometimes it transfers slower than that, but in general, it's about 6 gigabit per second. So we can do transfer from drive to transfer from drive to drive, or drive to system to drive. So that's basically for in and out for the data. Even right. 22. What is the purpose of UEFI? And on all the new systems, it uses UEFI instead of BIOS. It's a way of keeping track of connected components, to test device if it's on, to check for error, and to set up boot. So in order for your computer to boot, UEFI check to see what components are connected. Are they connected successfully? Is there any error, like hard drive, optical drive, motherboard, RAM, all of those things to make things to work. It check for error. If there's no error, it would set up boot, which is it's going to go to the boot section of the drive that's marked as active, and it's going to bring up the OS. So all of this is done in less than a second when you turn on your computer. Depends on how fast your computer is, right? Sometimes you have a slow computer that might go for, close to a minute. But on all the new modern computer, it's very quick. Boom, it's on. Okay, so we touched a little bit on processor last week. I mentioned a little bit of it in the motherboard and showing you, where's pin 1 on the CPU. Some of the things that are very important when you look for replacement or upgrade of CPU is number 1, form factor. Outside of just the physical side, Intel and AMD, they are not the same physically, and socket. Think of it like earlier, going back to the analogy, different cars, right? If you're trying to take a Ford motor and you're trying to put it into, let's say, a Honda, that won't fit. It's going to need major modification. It's never going to fit, right? Out of the box. So if you're buying an Intel processor, you have to have a motherboard for the Intel. If you're buying an AMD processor, you have to have the AMD compatible motherboard. And the socket is important. Think of it like rims and tires. You go and replace your tire, right? They ask you what size is the radial, what's the size of your rim or your wheel, right? And then it would have the specs. So So if you're trying to fit something small into a larger socket, obviously it's not going to fit. So socket has a number, and that number is essential. So I want to pull up something for you real quick. Okay. So let's say that I want to buy an i9 Intel processor. And that's the latest one from Intel. There's different generation of i7 also updated as well. So let's say that I wanted to get this one from Best Buy. Okay. Here is the socket number for the Intel. Intel always uses LGA. It stands for Land Grid Array. And it would have a number. So when you buy the motherboard, you refer to this LGA socket number to get the matching motherboard. Okay. Outside of, you know, the generation, the speed, the core. So we care about this number, the speed. And then if we overclock it or turbocharge it, it's 5 gigs. That's great, right? So for those of you who are gaming, you're able to boost it and get more performance out of your processor. But on average, it's going to throttle at 3.6, which is for most of our use, like surfing the internet, checking our email, doing Canvas assignments, looking at website. Now, if you're, you know, streaming video or playing game, you want a little bit more juice, and you can turbocharge it. You can crank it up. And they have software tool for you to do that. You don't have to overclock it manually into the setting anymore. Okay. All right. So now on this one, I think it's $389, which is fairly cheaper than what it was before, but you have different grade of i9. So a lot of people say, oh, I want i7, but they don't know that there's different type of i7. It's kind of like you telling me that you want a truck to drive, right? There's different type of pickup trucks. Right? Do you want dual cab? Do you want extended cab? What do you want, right? So there's different grade, different type of i7, i9, i5. And if you want virtualization, you need to go i5 and higher. Okay. Now, some have better feature than other. So when you're looking at the processor, a lot of the time we look at the speed, we look at the compatibility with the motherboard, right? And also, you know, user rating and different things. I like Intel as far as stability and such. I do own Intel system, but a lot of the time when I build AMD system because it's affordable. You get more bang out of your buck. So, and you know, so you just use AMD compatible board. So let's look at that. Let's say that I want the Ryzen 7, which is the later one for, they have like the newer ones now, but this one is pretty recent. So this is the Ryzen 7. Let me find one that gives you the spec. So let's pick this one from Amazon. So this one, it's an AMD. An AMD core design is a little bit different. Okay. It tells me the cache size, that's important to also include, also on the Intel, but it's using the socket AM4. So for AMD, the more recent processor, it uses the AM4 socket. So you need to look for the motherboard that will fill that. And you have website like PC Builder website to find the you know, matching motherboard, but out of your own knowledge, you should look for that socket number and use that socket number to find the motherboard. And also there's different generation in AMD. Some motherboard is for second generation Ryzen, like I was looking at the Ryzen 5, right? There's different generation motherboard with the different generation processor. So they need to go hand in hand. Okay? But that's the socket. So this one 4.1 gigahertz, and compare that to the i9, it is cheaper. Okay, $269.99. In the past, historically, AMD runs hotter, but I don't think so. I think the Ryzen series is great. Um, I like AMD. I like Intel too, but Intel you buying more for brand. Okay. So importantly, to answer the next few questions before we start working on the lab, if we don't finish, I'll pick it up next week. Okay. So CPU form factor, socket on the motherboard, graphic features. I should put in cache here, cache size, and it will say like 8 meg, 11 meg. So that's static RAM that's actually incorporated. It's stored inside the processor, and you want a good size of the cache for CPU. Because it's able to revert back to that for frequently used type of data. Now we care about 64-bit or 32-bit. Most of our recent processor are for 64-bit, but if you're looking at the older system, that would only be 32-bit or even older 16-bit. All right, heatsink. Some processor comes with a fan and a heatsink that goes on top. Okay. In the computer earlier, you saw that there's a little fan mounted on top of my processor. What that does is think of it like fins. They're little metal fins that pulls all the heat from the processor, and it sends it to the fan, and the fan's gonna send it into the case and get circulated out of the case. So it absorbs heat. Now the vertically mounted heat sink sends air vertically to case fan from the CPU, where the horizontal mounted heatsink circulates the air horizontally from the side of the case fan. And even if you're using liquid cool, what that does is it's using the liquid tube to cool it, but it's still using the fan to fan that out. So in my opinion, liquid cool is great if you're hardcore gaming, if you're using your processor a lot. But I don't think it's necessary to liquid cool if you're using your system regularly. Like if you just build a computer to, do school work or run some simple business application, it doesn't really need to liquid cool. Yeah, because you spend extra money for something that you're not going to really use. So this is the difference between the vertically mounted heatsink and the horizontally mounted heatsink. It just sends it from, one is going to send it upward to the case fan from the CPU, and then the other one, it sends it horizontally on the side. It sends it horizontally to the case fan. And on an active heatsink, it would consist of a fan. In most cases, you see that. Whereas a passive heatsink, it doesn't include the fan. So when you're looking at heatsink, right, like if, for example, if I go in here and I buy a heatsink, okay, heatsink in general that doesn't have a fan, this is passive. Okay. But if I'm looking for something for like AMD, like this, it has a fan that's active. Any questions? Okay. We touched on thermal paste last week. So thermal paste is used when installing a heatsink. It's used to act as an adhesive and also a cooling component. And if you're replacing CPU, you need to have thermal paste because you're going to take out the one that's dried already on it. So you clean it with alcohol, You can use something that doesn't have a lot of lint, like coffee filter, and then clean that out. Let it dry, and then apply a pea size, which is like your pinky. In the middle of it, you can spread it evenly. Some of them will come with a little spreader, like spatula. And Arctic Silver is a common brand.
Is thermal paste like a glue?
It is kind of a glue, but it's a pasty product. So Arctic Silver, it looks grayish. Most of them, they look grayish. I'll pull up one for you so you can see. And they range from a few dollars. So they come in a tube like this, right? And so it has a little spatula, this one. So it's called thermal compound as well. So it works. It's not truly a glue. It's more of like a cooling paste. And what it does, it sits between your heatsink and the processor, and you need that because the processor is very hot when it's running.
So this handles metal heat better, I would say.
Yes. So basically, think of it like an insulator, you know, or, you know, like if your skin gets very hot and you would apply some kind of, you know, lotion or something on it, it would act like that. So you would.
You're gonna need this in the future, right? Like during this course.
No, only if you're replacing your processor in your project. If you are doing that, then yes, you would need a thermal paste. But if you don't, if you're just upgrading memory, you don't need that.
Okay.
Okay. So well, I'm going to pause here, and then next week I'm going to pick up and finish out the rest of this assignment. And of course, you can turn it in next week. But if you can, you can if you want, you can read through the notes and answer it on your own, so you can submit it early if you like. I want to touch on the lab a little bit, and you can do the lab after class or during the week. It's short. It doesn't take very long. I took some time off of the lab today, but so I wrote a couple set of instructions for this because I wasn't sure if you're all running Windows or not. I heard that some of you were running Mac OS. Okay. And if you are having an issue installing this, email me and let me know. But on the Windows, you're going to go and download CPU ID software. This is a really cool software that actually, it shows you what is happening with your processor. Okay. So once you go in and you download it, you're going to run the installation. So this is what the website looks like. Okay. Don't click the advertisement, and likely that you would, you know, you might need to register to be able to download. Okay. Be careful of the advertisement. A lot of these download buttons are advertisement. So, so click Setup English. This one. Okay. This one. Okay. Classic version. You don't need anything else. So the purple, again, click the English setup button for if you're using Windows. Click download. Okay. Once you download, you're going to get an executable, and then, you know, and then you're going to run the executable. So what it will do is we'll look at your processor. It's going to tell you how many threads, what kind of processor you're using, etc. Okay. I try to find the comparable one for Mac OS, and the closest one that I found is in Part B. So if you're using Mac OS installation, you need to refer to Part B. Okay. So if you're in Windows, after you install, go through, it will tell you what you need to do, look at certain tab, answer some questions, and you'll be done with that one. Okay. The cool thing, yes.
Do you download this on the computer that we're using, like with class, or you download it on the computer you're fixing?
You should download, you can download it on the computer that you're using for class. It's fine. What it does is it's just look at your processor. It'll tell you what kind of processor it is. And it's a good application to keep it. And if you want, you can install it onto the computer that you're fixing. If you want to be safe, that's fine too.
Okay.
So a good way that we can do this also to check. So command prompt in Windows is a command line. Everything that you use to click and point, it can be done through command prompt. But so here's command prompt, okay? And in command prompt, after you open it using CMD, so I just type in CMD in my search bar and press enter and it opens it up. If you issue this command, open WMIC CPU get caption, it's gonna tell you what your processor information is in command line. Okay, so follow step 11 in command prompt to see what it says, and it will tell you your CPU ID. So it's like a summarized version of the CPU Z, right? A very brief, you know, information that's going to be provided through command prompt. Okay, so make sure you complete that step. Now, if you're running Mac OS, this software, right, menu meters doesn't support a certain version. So if you're running like in 10.11, it's not compatible for the Mac OS. Ideally, it would be 10.4 later, except for 10.11. So you would visit this website, and then you would it would give you the .pkg file that's for Mac OS, and then you would run the installation. If you get prompted with anything that says, "Oh, you know, this is blocked," or you know, then you have to enable it. You have to allow it to install. But it's very simple. It's going to give you the system percentage of the CPU usage and the user. And then it kind of graphs everything out. But you can select different tabs to choose how the graph would be. So it's similar to CPU Z. It doesn't have as many features, but it shows you how you can use tool to manage your processor, especially if you're using your processor for gaming or high-end application. Okay, so I wrote two set of instructions, one for Windows and one for Mac, depending on the type of operating system. So you can, and when you're done, you can uninstall it. That's fine with me. I just want to introduce you to some of the tools that you can use. Now in Finder, you can go to the application folder and then the utility folder in the Mac OS, then you can open up Terminal. Similarly to command prompt, you can input system profiler hardware data type. It will give you some more information about your processor. So that's one way that you can also find out for your Apple system, right, what type of processor it is. Apple has announced that they're gonna stop using Intel processor in their new iMac. I think they have already. And they have produced their own processor. So, you know, the iMacs and the MacBook that's been sold with Intel, soon they will not sell new system that has Intel technology anymore, because it's just, you know, they want to control the proprietary product, so they want to be able to use their own processor. So you see a lot of that now with Apple, they manufacture their own. So after you complete that, so Windows do part A, Mac OS do part B, both do part C. Okay, after you finish part A for Windows, go to part C. It tells you that. If you have Mac, do part B and then go to part C. Okay. So I want you to use the internet, and you can locate an Intel and an AMD processor that has integrated graphic processor unit. That means that it has a built-in video adapter capability. And if you search for it, for example, I just go to Google, or a search engine, and I just look up Intel processor with integrated graphics. I typed that wrong. So it tells me which processor it is, right? And I can pick starting from the i5 and forward. There are many of them. Okay. So like this i7, it has integrated graphics. So you will find one, pick one. You don't have to use Intel, you can use AMD. So once you pick one, give me the general description of it, what it is, what brand it is, model, put the URL. For 14, a sound engineer wants to add a sound adapter to his PC for sound capturing project. The PC motherboard has PCIe X16 and PCIe X4 slots available. Use your computer browser to visit an internet website to locate a sound adapter for the sound engineer. Remember that he needs sound capture adapter. Find one that's less than $300, and then you just give me the details of it. So if that's easy, we can go in and we can say sound capture adapter or sound capture card. Okay, but for PC. So there's one for USB, but I want you to find one that has it's an actual card that you can install. So you might want to dig into it and look for PCI X4, right? Sound adapter, but they sell mostly in USB now. So look for the sound adapter for the sound capture card for this. The last semester when I looked this up, I found one for $150 easily. So you can find one for less than $300 for sure. Okay. For last one, for number 15, given the CPU Intel Core i9, right? Coffee Lake 8 core, 16 thread, 3.6, etc. So this is the type of processor. Remember, this is the socket number right here, LGA1151. I want you to find a compatible motherboard. Any brand is fine. You know, if you favor MSI, Asus, you know, whatever brand you want, as long as it's able to adapt this processor. I want you to look for 16 gig of RAM, a video card, and a hard drive, and a power supply unit. All components combined cannot exceed $1,000. We already took out the processor, so motherboard, RAM, video adapter, hard drive, and PSU, power supply, cannot be more than $1,000. So I wanted to see how well you do with budget to build a computer. Okay, so if you're thinking of blowing $700 on a motherboard, then you got to cut back on the other parts, and that will be very difficult to buy all the other parts with the $200 that's left. So think about how we can be efficient with the budget, because we do this for business all the time in consulting and installation, that we quote them on a system that we can have for them and then be able to, and you want to be able to profit as well. So, okay. So once you find the information, put the information there, like just the general spec is okay, and you can give me the URL. So I want to see how well you do with looking at parts to build systems or to fulfill business needs. When you're done, you can submit a document with all the information and the answers to Canvas. That will be for lab 2. Now that's not due until next Saturday, so, and we're coming close to the end now. Any question?
Nope.
Okay, thank you so much. It's been 4 hours. Um, I'm available in email. I'm not doing anything much except for grading my classes. So I hope you enjoy your Labor Day. Sorry, I took up your Saturday because of class. I know.
Oh, sorry, I do have a question.
Sure.
What do you make of those mini computers? They're like $200 and they have like 8 GB RAM and it has a Windows 10 on it.
It's okay if you use it for a very basic purpose, like checking email, surfing the internet. You know, if you have little kids that want to use the computer just to look up stuff and watch YouTube videos, okay. But when you start using it for other things, it might get a little buggy, slow.
So not good, like cybersecurity wise, you can't really secure those.
You can. It's really how you use the system. It's not just about the system, it's how you use the system. So you can put like anti-malware on it. You can use it with a VPN. There are a lot of things that we can do with it. You know, if you can use an iPad or a tablet to access the internet, why not those systems? But yeah, you want to have some security application installed.
Thank you.
Okay, you're welcome. All right, if you want, you can type in your name, right, to make sure that I get you for attendance, but I do pull the attendance participation list. So, okay. Well, I hope you have a wonderful weekend. If you don't have any question, I'll stay on for another few minutes, and I'll see you here next Saturday. We'll finish up the assignment next week.
Where do I put my, do I put my attendance on chat? My name on chat?
Yeah, just type your full name.
Okay, thank you.
You're welcome. Type your full name in chat. Work on your project, everybody.
Thank you.
You're welcome. Have a wonderful Labor Day. Be safe.
Thank you.
You're welcome. Bye.
Yeah, I had a question about last week. The very last question of the assignment, the 3 main types of data synchronization. What were they?
Cloud. Oh, for the data type, let me go back. For the cloud synchronization, you mean?
Yeah, it says where'd my paper go? Data synchronization, I believe.
I'll open it up. Give me a second.
Yeah, it says identify the 3 main types of data synchronization methods.
Yeah, so let's think about it. On your phone right now, what kind of data do you back up on the cloud? Do you use an iPhone or an Android?
I have Android.
You have an Android. So
Yeah.
you probably use like Google, right?
Yes.
Okay. So what do you normally put up on cloud just to make sure that you have it in the future?
Pictures,
Good.
contacts.
Yes. Yeah. Put those. Picture, contacts. Sometimes could be video. Sometimes people would do video if like it's a family.
Well, it had said methods, so I thought it was like, you know, how we were synchronizing, not what we were synchronizing.
So for the so for the 3 main types of data synchronizing methods, so you would use the cloud, right? You would sync it to cloud. You see my screen right now, I'm sure. You would sync it to your car, of course. Like I listen to music in my car all the time.
Yeah.
Using my phone. You would sync it to your computer, like your laptop or your desktop, so that when you would have pictures of your kids or, you know, email, etc. And then you would sync it from one device to another. Like some people would do like their smartwatch with their smartphone or, you know, so those would be the type of, it should say communication synchronization, but that would be the type. And then for 33, that would be the the data type would be contacts, email, apps, music, video. There could be more.
Okay, I get it. I understand.
Yeah, no problem.
And I had one other question and I can't find it right now.
That's okay.
Or maybe not. I have an answer for it, so maybe I didn't have a question.
If you could think of it, you can always shoot me a Canvas message or an email. Either
Okay.
way. Okay?
Okay, thank you very much.
You're welcome. Have a wonderful Labor Day.
You too.
Thank you. Yes.
For week 1, last week's a quiz. What do you recommend that we have to study? What is it? What's the quiz based on?
It's based on the assignments and notes.
Oh, okay.
But you have 3 attempts. So let's say you take it the first time and you don't like your score, you can always go back and take it again. So you can do it 3 times, and the highest score in those times will be reported.
Do you happen to know how long it is?
It's 10 questions. I know it because I write it. I write all my own quizzes. I don't use bank quizzes because, they don't tie. Sometimes they don't tie to my discussion with my students. So, yeah, they're 10 questions, 5 points each.
Okay, thank you.
You're welcome. Any questions? No more questions? Okay, I'm going to sign off now. I hope you enjoy the rest of your weekend.